This is a New York Institute of Technology Thesis studio. The studio is working on an installation for the Venice Biennale at Palazzo Bembo. We just found out as of yesterday that the Venice Biennale has been delayed 1 year, but we are not sure what's going to happen with the satellite exhibition venues. So we are trying to figure that out. We also got interrupted by the pandemics. So I'm asking again if you can all mute your mics if you're not speaking so that we don't have background noise. Thank you. So I would like first of all to introduce our distinguished guest reviewers. We have the honor of counting with, I'm going to actually start with alphabetical order. Mario Carpo, who is a professor from Bartlett in London. So thank you, Mario, for joining us. Mario has been responsible for activating what I would argue is perhaps for the first time since around 2010, histories and theories of technology in relationship to computation. So I really appreciate Mario joining us, especially because he has been at the foreground of the discussion of the digital, computational design, and so on. So thank you for joining us. We also have the honor of having Cynthia Davidson. I know Cynthia Davidson for a while. We collaborated together, so I really appreciate Cynthia taking your time to be here. Cynthia, as you all know, these are people that they don't need introduction, of course, but I'm going to go through the introduction to make sure that the younger generations, perhaps they are more aware of the weight of their careers. Cynthia is the director of Anyone Corporation, who has been responsible of curating an impressive set of discussions in the 1990s. Now is the editor of Log magazine, who is also responsible for the discussion of history and theories, contemporary theories of architecture, especially in the US, and is a magazine that is actually present everywhere in the world. So thank you, Cynthia, for taking the time for being with us. We're also going to be joined, perhaps in a couple of minutes or later on, Alessandro Melis. Alessandro is currently a professor in Portsmouth University, but also the curator of the...
Pablo.
What?
No, I'm here, I said.
Ah, you're here. Okay, I didn't see you joining. Perfect. Sure. Alessandro, we had just recently a meeting with Alessandro. Thank you again for taking the time. Now you have a little more time, it seems, because the Biennale was just recently delayed for a year. But thank you for taking the time, because I know that you're very busy organizing all the events. So I was saying Alessandro is the curator of the Italian pavilion at the Venice Biennale. So thank you for joining us, and also professor of architecture at Portsmouth University. We're also joined by Fred Lebrat. Fred is a usual suspect in my reviews. Fred is a professor from here in New York City. So by the way, we have people from all over the world, but also people from New York City. Fred is a practitioner and also professor at Pratt. So thank you, Fred, for coming. We also are joined by Galia Salomonov. He's going to join us a little later, a professor in practice from Columbia University. And here we have also Maider Llaguno, who Maider is a partner of Alejandro Seraporo Llaguno, based in London, but also doing a very interesting postdoc at Princeton University on the relation between science, environment, and architecture. And we also have Sandra Manninger, who is a principal of SPAN architecture, and also a professor in practice of Michigan University. So thank you for being here. I'm going to briefly, obviously here I'm seeing in the list, we have some reviewers also from NYIT. I just mentioned Dean Maria Perbellini is with us, so thank you, Maria, for visiting us and for being part of the review. Tom Verebes, who I mentioned before, and also Christian Pongras, who is the senior advisor for the provost. So thank you. Christian also has been participating, as well as Tom Verebes, in many of our reviews, so they're familiar with what we're trying to do. I'm going to briefly introduce you to the studio. I sent you a studio brief, and what's going on relative to the brief. As you know, we had the plan of building a one-to-one small installation in Venice. The plan was cut by the pandemic. Obviously, we could not access the Fab Lab at our school, so we need to change plans and come up with different strategies. So today, the students are going to show you what they have been working on. Additionally, in addition to the changing the scope of the installation relative to the pandemic, half of the class also donated their time to work on personal protective equipment for hospitals, using some of the technologies and techniques that they learned in this studio. One of the ideas is, if we can have your attention during the review, is to see articulations not only between the architecture of the space, digital fabrication and algorithms, but also what's happening relative to the scale of the body, relative to mask, equipments, and so on. This studio has also been very interesting for me because it is a little bit of an experimental mock-up of an upcoming Masters of Science in Architectural Computational Technologies that we are co-developing with Dean Perbellini and Associate Dean Verebes, and I'm going to be directing, hopefully this year, if not next year. One of the issues that I wanted to share with you is the particular relationship that we're trying to activate in terms of computational technologies. Students were asked to not only learn some of the contemporary issues in terms of digital technologies, but also analyze and displace these technologies in relationship to algorithms, right? Virtual modeling or computational design, mechanic automated design, and also slightly looking at robotics, robotic fabrication methods, and so on. One of the issues that I would like to perhaps discuss and see how students are starting to address is the critique of technological determination. In other words, what we have been seeing in the last 20 years or 30 years now is that architecture schools all over the world try to catch up with the latest technology, the latest fabrication tool, and so on. And there is, I would argue, there is very little agency on behalf of architecture as a cultural discipline in relationship to the incorporation of digital technologies. That took me to organize in 2010 the Acadia conference, in which I was claiming that the architects as designers, they had a limited amount of authorship in terms of software developers. In other words, if you were using Maya, if you were using Rhino, if you were using a certain fabrication tool, you were kind of within a range of possibilities that technology would allow you to do. In that sense, I'm interested in expanding relationship between drawing and building by having students analyze and also create their own computational systems, as well as their own robotic fabrication systems. This is an undergraduate class, so they started addressing some of these issues. Obviously, they did not arrive to create their own, completely their own system, but they are starting to be critical of the relationship between technology and space activation in those terms. We also activated a structural relationship between history and theories of architecture. We look at Brunelleschi perspective as a system of representation, as the invention, a creation of a system of representation. Then Borromini as a simulation of that system of representation in Palazzo Spada. We look at Palladio critiquing perspective as a system of representation. And we also look at Andrea Pozzo trying to activate a tension between a virtual type of projection of the space in relationship to the physicality of the space. The studio, as I said, is focusing on computational design and specifically on simulation. We took computational simulation as a way of understanding that in terms of automated design and robotic design, simulation is playing a specific role. Why? Because it's non-reversible. You cannot anticipate how a simulation is going to come up through an algorithm. So in other words, the simulations that we have been using, some of them are non-reversible and they're non-reducible. So in that sense, there is a specific theory about computation in the terms of why we're using a certain type of technology. We are also, we're trying to address a non-linear relationship between computational design in terms of digital design and robotic fabrication to avoid the typical thing that happens all over the world in all schools of architecture, which is you have an abstract model and that abstract model gets literally linearly built by a predetermined system, either 3D printing, robotic fabrication systems, and so on. So we try to expand relationships between drawing, automated drawing, and computational fabrication to activate non-linear relationships between the two. In other words, to think of them as actualizations. So this is perhaps a short introduction. You have the review you had time to review the syllabus. I don't know if you have any specific questions. If you don't, we can proceed to the first student, which is Andres Carcamo, who's going to introduce his project, as well as the first strategy for the room. I just want to clarify that the room is a tiny little room in Palazzo Bembo. It's only 2.5 meters wide by 5 meters deep, and is dealing with different aspects. We're simulating different aspects of the site specificity of the room, as well as what the students are doing in relationship to that. Maria, you want to say something?
Yes, thank you, Pablo. I want to take just a few 1 minute out of that important critique, and I want to thank you, Pablo, for the amazing work that you have been performing during the whole semester. Besides all the challenges and the emergency remote teaching mode that we have to address, particularly on a difficult studio like yours that is based on fabrication and making, right, as an integral part of your pedagogical approach. But I want to spend just 1 minute to thank all the prestigious guests that you are actually having today. Thank you all. We are grateful for your presence, for your time. It's going to be an amazing review, and the faculty and the students, on behalf of the school, I'm really, really happy to welcome you to our virtual thesis review. But I would also like to spend 1 second to recognize special students that you have in your studio, and particularly Ari Began, Jason Bottiglieri, Peter Leonardi, Alexandra Pannichela, and Karina Pena, and Benjamin Sather, that have been working with us in addressing PPE production, and also 3D printed face mask and shield components. They were designing, they were cutting, they were producing by themselves at home. I think is an incredible sign of how generous and how our students are, right? So we are, as a community, immensely proud of this group of students that were transitioning from a studio mode to actually a social engagement, and such an important efforts and commitment that they were showing to us and to our community. So I am immensely proud of your students, and I want to thank you, Pablo, for guiding them through this experience that will be for the entire life. They will remember that. So thank you.
Thank you, Maria,
for inviting me as well.
Yeah, well, thank you, and also thank you for your support. We couldn't be doing this unless it was for the amazing work that you're doing at the level of sponsorship, grants. We are working on this installation thanks to not only the IDC Foundation that is sponsoring our new programs that you are developing, Maria, that have a new vision about the use of technology in terms of architecture for New York Institute of Technology, but also specifically for this installation is possible by the SLab, which is an initiative that you put together, which we are also deeply appreciated. I also appreciate the jurors that they donated as per your request. They donated their honorariums to help for the student fund. So also we are very appreciative of their social commitment with the cause. So we're here, Anthony Caradona, Assistant Dean, has just joined us. So thank you, Anthony, also for being with us. We're going to proceed, unless somebody has a generic question about the studio. If anybody has a question, just let me know. Otherwise, we proceed with the first student. Any questions so far? Or any comments? Anybody wants to do any comment? No? All right. Okay, perfect. So, Andres, why don't we go ahead and you introduce what you have been trying to activate?
Okay. Can you please allow share screen?
Yeah, I think it is.
It's disabled.
Yeah. Is now? What about now?
Yes, thank you. Okay. Hi guys, my name is Andres Carcamo. Thank you all for coming. So my thesis attempts to activate the virtual and built world and reactivate architecture. The title of my thesis is Iconography in Architecture. So iconography is symbolic representation. It's the visual images and symbols used in a work of art to study and interpret that artwork. New trends in the field of architecture now place more emphasis on the aesthetic of built space. With a 3D aided design technologies, nearly anything is possible as long as you can imagine it. This, I believe, is causing architecture to be viewed more as objectively. So this focus on form finding is turning built spaces into more of sculptures. If architecture becomes an object, then we ourselves become obsolete as a profession. So in attempts to recover the function of architecture, we will break away from the conventional means of design and attempt to modify space through the use of perspective and the idea of infinity. With this principle, we will examine how objects become signifiers to inform space, visual space. We will then attempt to transform how we perceive depth within the visual realm and expand that depth into the intellectual realm. Much like how images inform interpretations of a painting, we will use what we see to inform the interpretation of how someone views space. So the work began with the analysis of iconic works that merge both the visual and the intellectual realm. So first, in attempting to understand Teatro Olimpico, we break it down into its few parts. One, the picture plane meant to structure a viewer into reality. Two, the visual cone that tricks your eye into believing that space is more than what it actually is. And the visual cone. Then we examined the fresco in the Spanish Steps of St. John. By manipulating the viewer's position in space, from where you stand, you can see either a landscape or you can either see St. John. And then finally, we analyzed Palazzo Spada. First, it structures a viewer and deceives them with a cleverly placed singular perspective. Move one thing. It's kind of structured in sort of rows that diminish through time. Here, groups of columns become planes that lead you to believe that the corridor is longer than what it actually is. Ending the research of my thesis, I kind of went back and tried to rebuild Palazzo Spada to understand more what's actually going on within the space, examining the breakdown of what we found, the placement of both two vanishing points and receding decays in space. So it starts with the real world space, and then through a system, it kind of reinterprets itself into a decaying rhythm. If I examine the placements of objects, we find how to manipulate the perspective and achieve an expansive or compressed space. This is one of the models that I did this semester to kind of hone in on the thesis. So the bigger picture. The bigger picture is that perspective is more of a visual scale than just something that you can use on paper. It's a way to kind of expand space in different ways that we normally wouldn't. So ending the research, we kind of went into more of a theoretical approach to expand. With the base research established, it led to kind of some different directions. First was the manipulation of multiple perspective points to achieve kind of different views, just trying to play with what can actually happen with this kind of idea. The treatment of the center columns in different perspectives. And this is just a model of one thing that was achieved, which is kind of a split view. almost like how three-dimensional technology works today. Next was kind of a path into anamorphosis or anamorphic perspective that allows you to warp space. The basic idea is you wrap a image around the column, and then within that column you see the actual image. And so we attempted to play with how people would walk around this space and how people would actually be visually informed by different things. And this was just a small aside, playing with the idea of how viewers see different things as they move around an installation. Lastly being one of my mock-ups for a full installation. Once that kind of aside was done with, that kind of iteration, I then went on to manipulating the perspective points of the visual field. So through different placements of the points, you can achieve different views and different ways of expansiveness. The manipulation of the second perspective point, which is this one, can either compress or expand space. So this was kind of key in honing in on what I wanted to do with the installation in Venice. And then finally, the best result was a space that kind of doubled your view of our small installation space in Venice. And it was best suited for all the requirements that were needed. Columns here are signifiers to descend space into kind of an infinite realm. And this was kind of my last mock-up. And just a quick note, these aren't exactly meant to be columns. These are more meant to be visual signifiers that kind of transform a space. So it could be done with anything that is going to be shown further in my research. And last semester's finished result. And basically what we get is an illusion of depth where the space feels more expansive than what it should. So we have a room right next to a same size room in Venice. And so ours would feel naturally longer than theirs, when in reality, they were both the same size. Once this sort of base research was finished, I then dove into manipulating space so it better fits the installation that we proposed. Basically applying the grid system that I developed for our room into my classmates' iterations. This is one G-code manipulation that I also worked on. So in addressing how technology can further inform our built space, we started manipulating kind of the code that 3D printers work with. So this is our class iteration. Sadly, I didn't have the latest model, but you get the best gist of it. So manipulation of the print information to better fit our needs for the installation. We can kind of skew the viewer's view. And so this is basically working with two different codes, trying to merge different things that wouldn't normally be your standard input in a 3D printer together. And so here we have a small simulation of what that actually looks like and what that does. This is a part of one of Ben's columns. It's meshing a wireframe printing and a spiral printing together. And then a few other tests were done while we were still at school. Sadly, I couldn't continue the research just because of the whole epidemic that happened. I didn't have a 3D printer at home. So here we kind of have a few different things. We have kind of a heat manipulation in which we raise the temperature incrementally in the 3D print. It failed, but it also gave us kind of an emergent pattern. Here we have a different heat manipulation where it has different forms of adhesion within the printer. Another heat manipulation that establishes another emergent pattern. And this was just some research that I did to further advance the combination of information that Pablo had asked me to do in order to kind of build on our 3D print information. So one of our classmates has been working on structural simulation. And so with that, we wanted to combine our structural simulation, our G-code manipulation, and our built works into something cohesive that we can then present for Venice. So here I have my classmate Alex's column. It might not be the latest, but it's the one that we work with, combining everything into one built work. Here we have our classmate's Ben's columns, combining a wireprint, a structural simulation, and his column into something that represents it. And here we have a G-code manipulation of modifying his column to better suit different needs that we have. So it goes from spiral to wire to normal back to wireprint. Same sort of gist. One of my other classmates' columns. And the end result in this was basically making drawings for the installation that cohesively bring projects together and also form into my visual perspective. And the final room, a view from the opposite side in. And that's all I have. Thank you.
I have to clarify that the students work as an overall class, but also they work individually in portions of the installation. So we went back and forth working with individual theses and group installation pieces. Andres, you don't have a view of the opposite side, of the perspective side with the drawings?
I don't have that view, no, sorry.
Okay, so you did the other one. You have been working with, anyway.
I don't have that view because the back wall is blank due to our.
All right, but we are also working on an animation that some other students also want to explain, right? But in any case,
yeah.
The idea is now that perhaps since we have so many reviewers, I paired certain projects with certain reviewers, and since Mario Carpo says that he has to leave soon, I would like to invite Mario Carpo and Cynthia Davidson, as well as Alessandro Melis, if you have any comments on the project. Thank you, Andres.
Should I go first?
Yes, whoever wants. Yeah, go for it. Yeah, go for it.
Well, I particularly cherish the first part of the presentation on perspective and perspectival renderings. These are students of, I missed that, which year? These are undergraduates, right? First year, second year, third year?
This is thesis, fifth year thesis. By the way, I have to also say that the students, they did never really work with algorithms, so it's the first time that they're addressing computational design, but it's their finishing year, the last year of undergraduate, fifth year, yeah.
That's remarkable work for, congratulations for an undergraduate. This is very smart, interesting work. I focus on the first part, the perspectival, because it reminded me of what I did when I was a student, except we didn't have computers back then. So we had to do everything by mathematical formulas or by ink drawings. But I was wondering, just as a footnote and a general remark, I noticed a certain resurgence of interest in perspectival representation just in the last few months. And I was wondering to what extent there may not be some inherent nostalgia in our attitude vis-a-vis perspectival images, because we are living in a world where perspectival representation are becoming less and less relevant. Because basically photographic images, which are perspectival drawings made by a machine, are being replaced by technical change. The next generation, and sometimes the current generation of phones like this one, when they take a snapshot, they don't really take an imprint of a perspectival view, the Albertian way, but they actually register a 3D scan of a volumetric object. The technology is shifting from taking a record of a perspectival projection to projecting a scan of a three-dimensional volume, even though when we navigate these scans through images. but what we capture and what we record is more and more a 3D scan. So we are moving from perspectival projection to volumetrical renderings in the way we capture them. And my feeling is that next in line is in the way we visit them, because more and more images, which are separated by Alberti's perspectival, picture plan, the plane which keeps the viewer and the image apart, we are going to shift into a universe where immersive tools of augmented reality and virtual reality are going to replace the perspectival separation between the viewer and the projection. My feeling is that if Alberti were here today, he would notice that we are shifting from his on painting to his on sculpture, because the technology we are using today is shifting from the two-dimensional planar projection painting to three-dimensional virtual solid volumetric rendering. I feel this is what is happening. And if that happens, perspective will count for less because volumes will count for more.
Mm-hmm.
Just a feeling. I don't know if it is a good thing or a bad thing, but I have a feeling that this is happening.
I want to agree with you, Mario. The pedagogical objective, and this is a little bit of my limitation. I totally agree with what you're saying. And also, the idea was to get into 3D scanning, but we couldn't arrive there. But the idea was to take them through the history theory of representation so that they understand the motivation of the designer in terms of activating something in terms of the system of representation. But I think that they understood that and they got stuck into that one. And hopefully the idea was to increase and bring them to contemporary problems in relationship to AI related to the digital cameras and 3D scanning. But Andres, you want to say something in relation to what Mario said?
Well, I want to agree with it. The kind of like how the camera took paintings out of the picture, since you no longer need to paint anything to capture it, and then informed kind of this cubism error. It's the same thing that's happening with three-dimensional technology versus perspective views. Yeah, I feel like it's changed. The error is changing, and so we have to kind of revive that.
An inevitable technical shift from 2D, which was a data compression technology, to 3D, which until recently was too data heavy to be user-friendly. And now it's just coming because it costs the same. So the next generation of machines will just do it, even if we don't need it, just because it's coming.
Cynthia or Alessandro, any comment? Cynthia, you're muted.
Yeah, I know. Yeah. I have to find the cursor and the arrow and all that stuff, which speaks to my my knowledge of technology, shall we say. Pablo, so I'm here, as I understand it, because of my curatorial work and work with exhibition designers, because I cannot talk the language that Mario talks or that Andres is talking, because I can barely log into Zoom, right? So I can only look at the effect. And the effect right now, I can only look at images that he showed that were very provocative, and I wished I had a bigger than normal computer screen so that hopefully I could see these things in greater detail. I think using the forced perspective of Palazzo Spada is very, very effective for an installation, particularly a very small space. I know the spaces in Palazzo Bembo. They're extremely difficult to do anything in. I think my question would be less about technology and more about effect. And what effects, Andres, were you hoping to achieve, assuming that you could actually build something that looked like you're drawing? How did you envision the viewer interacting with it? I like this idea of, extending space, but that's kind of, it doesn't seem like it's the only idea you have there. I'm not sure.
Well, the effect was to bring architecture into a work that was supposed to be more sculptural. So within Palazzo Bembo, we are given a space, and I kind of wanted to take that and make it our own in a way that it feels like we are breaking the rules of that building itself. So the room would be more expansive and also kind of interact with how you see things from certain points of views and how you interact with the actual work in installation itself. So throughout you're walking through the installation, the pieces themselves also shift in relationship to where you stand, and the views kind of never change. Will always change, actually.
So when you say this space becomes more expansive, it doesn't literally become more expansive because you're hemmed in by these walls. So
Yes.
Is it just a fool the eye experience
fool
for the viewer? And what did you expect if I walked into that space because you had successfully installed it? What did you how did you expect me to respond to it? Well, not expect. How did you want me to respond to it?
It's more of a head scratcher because we also use the room next to us as kind of a staple in space because they're supposed to be the same size. So you walk in, you see one room short and stubby, and we're also on the far end, and you see this other room and it's long and expansive, and then all of a sudden you go, am I still in the same place I was just now? If it was installed correctly.
I also have to clarify that at the end of this 2-hour term, a student is going to show the virtual reality navigation, which also works with that idea. You know, things, you know, the relation between individual thesis and the group is something that we can only grasp until the last person presents. So it's a little bit the challenge of the review, I guess.
But and that's the feeling I had listening to Andres, because I thought, well, what did the next person do? Because I feel like I want a comparison situation here in order to really understand what the studio is about.
Yeah.
So it's hard to just speak about what he has shown us, even though he has said, this is by this person, this is by this person.
Yes, it's impossible.
So I feel like we need another 2 or 3 in order to really understand what you were doing.
So unless, Alessandro, you have a comment, we can go to the next student, and then perhaps we build up with a
quick question, maybe, if it's possible.
Yeah.
I mean, I was very impressed by the first sentence that you started with, Andres, saying, attempt to recover the function of architecture. Could you elaborate what's the function of architecture, since you know what it is about? It seems a lot of us here are a bit lost, and we would love to learn from you. You know,
he has big phrases, Andres. You know?
Well, I would argue that we kind of design our own function in architecture. I was trying to step away from the sculptural aspect that architecture is becoming, and since this was an installation space, I wanted to further enforce that architecture is a kind of an experience rather than a visual pleasing sculpture.
No, I mean, that's a good statement, but for me, it's very interesting and very important. I really think that this topic of how much we live in a physical environment, into a visual environment, into a virtual environment is more appropriate now than it has ever been. And I think architecture is at that kind of hinge between the virtual, the visual, and the physical. And to critically address those relations and to say that architecture has a role to make you, you know, experience space and versus visually perceived space, physically perceived space, haptic, mental, in that sense, virtual understanding of projection as a way to experience and educate our senses through experience. I think there's a lot there that you could look at, not just on a playfulness way, but even in a fairly serious way, as a way to decode information, to absorb information. And especially today with a kind of political environment and information that we receive, it's quite essential to be able to understand how visual or abstract information can be related to our environment.
Yeah, I agree.
So I don't know if that's a function of architecture, but that's one of the potential function of architecture.
I agree.
All right, so maybe let's move to the next one, and we keep perhaps, so Brianna is next. Brianna, if you can make a fast, short presentation so that the reviewers can understand a little bit more the entire installation in relationship to the individual fragments, would be great.
Okay, I will try. Let me share my screen and start my presentation. Okay, so my name is Brianna Lopez, and the title of my thesis is Parametric Flow. I'll just summarize this, but essentially my thesis was using simulation-based modeling to create different spaces based around a shell structure, as well as looking at systems of flow lines based off of initially a water runoff simulation, and then furthering to different type of flow line kind of simulations. I started off looking at landscape topography, and essentially looking at how when water runs either through a river bifurcating like you see in this image here, or simply just a water runoff, the kind of negative that it leaves in the landscape, and how that essentially could resemble, which I'll show here, sort of a branching off, kind of like a tree, either being the roots or the branches, but essentially creating a structure. This was just another study with a more peaked version of landscape rather than a more flat version like I showed before. Trying to then take that idea of the lines created by the water flow or runoff. I started doing CNC studies, but they kind of were a bit of a dead end, which then got me thinking about how the landscape actually would look after being affected from a water runoff, and how it would kind of start to resemble a canopy or shell system. So that became a major point of my thesis, beginning with looking at shell structure typologies, and also trying to, of course, relate back to that initial idea of looking at the water runoff and the structure that the kind of flow would have. This is just showing a basic kind of scripts that I was working with. These were the first set of typologies. And of course, I worked with different parameters for these, but the main focus that I was thinking of with these shells was to look at the effects or difference between the positive and a negative that the shell would actually create, as well as how you could actually occupy or interact with the shell, whether you can be underneath it, inside of it, or just looking out from it. That was important for the installation version as well. This is another set of typologies, which I also wanted to see essentially how I could test the limits in creating these shell structures, where it would still remain structural yet be a bit exaggerated. These are just a couple of the study models that I had done for the more basic versions. And then, of course, relating it back to the water runoff, and just really, this was kind of like a smaller study in looking at the patterns or structure that the runoff would have on the various shells interacting with it. This would be showing how I related the two again, starting off with a basic or a simpler shell, expanding on it, and then finalizing with adding the kind of water runoff on top of it to start creating an idea of mapping lines. So that's this image here, is just the plan view of it. So it starts to create the idea of kind of just a mapping sort of pattern. Of course, we have our installation, which is the most important thing. And we did decide to do a fragmented version, wherein each student essentially has a fragment of their project. So I actually have it here. And my final shell, I'm showing it a little early, but just so that you can get a better sense of the whole installation overall. And you can see that the shell became very vital to the project because it is the first thing that the viewer would interact with when they enter the space. These were just a diagram showing the overall kind of concept on how I would start with a basic shell and then kind of try to transform it in different ways to be more detailed, and some full room studies that I had done. What I was focusing on in these studies, my initial studies, was looking at how the shell could essentially be seen as first a surface, then come down to more of a line in representing as like a column, and finally leading off with a point. So this was one of the final kind of full installation versions that I had come up with. Another thing that was important, besides kind of the positive negative aspect of the shell, was also looking at it in plan to see if there was a way for me to kind of design it so that when looking at it in plan, it would resemble a fragment of the water runoff shown in the landscape image that I showed previously. And like I said, we did decide to do a fragmented kind of installation. So these were some of the first steps that I took in trying to design that kind of final shell. And this here is the final shell, but kind of a base, because we of course did other studies. And those other studies were necessary because in our installation, we did decide that we would lower the ceiling, which goes back to kind of Andreas's grid and perspective view. So what that meant for my shell was that essentially it would be cut in half, which obviously means it would not necessarily be as structural as it once was. So I do just have a quick model here. And this model was actually printed upside down because trying to print it upright actually failed a few times. So again, not being structural in that sense, but it did work being printed upside down. I have then here a visual representation of the structural simulation and how the red being obviously less structural. And then the next portion was how we could optimize this, not only in terms of structural stability, but also in the sense of if we were actually going to build it in full scale in the installation space, how could we kind of separate those pieces so that they would still be able to remain the structural integrity and be able to kind of fit together without needing any additional joints. That was the GIF before. These were some first studies that I had looked at with a more organic approach, kind of a voxel way of doing things. This model showing how we looked at, again, those separating of the pieces for it to actually be built. But since things kind of changed, it went to be more of how we could represent this in the drawing or virtual reality format you'll see later on. I went back, of course, then to the water runoff simulation and how that could be represented with the new created shell that I have. And I did another study model of it, but I found it wasn't entirely structural. So I looked at a different method, which became the kind of basis for the rest of the thesis itself, which was looking at how this kind of lattice pattern formed, created by a swarm simulation, where this is entirely structural and obviously is very optimized as it uses less material, which is what we wanted. I took a lot of model photos of that. I also tested it in 2 different kind of filament styles, but I didn't want it to end there. I wanted to see how further I could optimize and how we could change it at the very least in drawing form potentially. So this was kind of a bit of a monster, I call this one. Looking back at the form initially of the swarm system and kind of letting it go a little bit wild, which this is very structural, but obviously it uses a lot of material and probably would be very difficult to put together. So I went back to, again, looking at those kind of lines created by the swarm with, let me see, there's an installation, I mean, a video of how it would work in the installation of the swarm. And you'll see this again later on in for other presentations as well. So I have then just a kind of model or rendered version of one of the simpler swarms that I created and also printed that as well. Unfortunately, due to the thinness of it, it did not fully print, so kind of had to start over a little bit again and looking at finally G-code manipulation, which again, many of my classmates also looked into. And it was important for my project for the not only the structural optimization, but again, looking at how we can bring technology to inform the space of our installation in different ways. This is kind of just a basic shell that's not altered, but just showing how the nozzle would kind of actually build the piece in a printer. I looked at, of course, then the wireframe, and I looked at it in different layer sizes, but as you can see, it wouldn't print all the way. We actually did try printing it and it did fail in both of these versions of the like kind of larger versus smaller scale wire print. So I initially just went back to the basics, or the more simpler way of manipulating the prints, which would be looking at the different layer heights, which was more successful. This is just comparing a normal print to then an altered print with the different heights, which was printed. And again, we had some issues with the thinner portions of the shell not printing fully, but the rest of the remaining shell is still very structurally stable. I did continue a little bit of those layering studies with the regular shell and the more complex lattice swarm. And the last image I'm just showing here are the lattice model again, as well as the kind of monster. So overall, just to kind of end my thesis statement, it essentially transformed from looking at the kind of negative or positive spaces created by a water runoff from a landscape to then how the positive and negative idea could translate to that of a shell structure, how that would change by the way that a person could interact with the shell, whether they're inside it or outside it. And then, of course, optimizing that shell related to a structural system and just various ways that we could represent it within our space.
Thank you. If you can put back the fragment drawing with all the installations so that the jurors understand the overall structure.
Sure.
Now we can continue. I don't know, Mario, Cynthia, Sandra, and Maider. Whoever wants to make comments.
Can I say something?
Yes. By the way, Cynthia, you were invited exactly for what you said before, so thank you.
Oh. Well, now I'm going to say something completely different.
Okay.
I'm really interested, Brianna, in how often you talked about things failing. And I want to ask you about what you learned from failure, because I think it's really, it's not, I haven't been on very many juries where students have said, it failed, it failed, it failed. And I really appreciate your acknowledging that things weren't turning out the way you had hoped they would turn out. So I'm sure you made many adjustments over the course of trying to get this to print. So I have a question. If you kept encountering failures, why did you keep going back to this flow of water on the landscape? Did you ever question if your original concept was part of the failure? What do you think was causing these failures?
Well, I actually kind of have to thank my professor for that, because he initially had told us that failures are good when we encounter these issues. So that did cross my mind, which is why I started looking into different ways or methods of representing the shell. But I kind of just wanted to try as much as possible to stick true to my kind of original thoughts, even if it was represented kind of instead of it being, you know, a water runoff, but then like a line flow where it kind of could still look at it in a similar way, but be represented a bit differently. That's kind of, you know, I just wanted to try to stick as much as possible to what I originally thought of.
Because you wouldn't expect anyone to go into this installation, would you, to say, oh, this is from water flow.
Right, exactly. Yeah, no, it totally, the water aspect did get lost, but what I took from that was essentially the actual flowing of the lines and how the lines could interact, like I said, bifurcating river-wise or in this kind of lattice form. That became more important than it necessarily being from water. I should rephrase that.
Can I say one word on behalf of the student, so in defense of the student? In computational simulation, particularly in structure, etc., failure doesn't have the negative connotation, but it does in daily life. Every process of optimization, when it's good, computational simulation, in fact, it's a trial and error process. But the only way to find a better result is to try blindly, and if necessary ad infinitum, a huge number of random tests. There is no way to know which way a test is going. You just shoot at 360 degrees. And you try once, and you try again, and you keep trying, and at some point, if you're lucky, you will find a solution which is not necessarily the best, but it is as good as you need it to be. This is what we call optimization, which, by the way, is not the way an engineer would solve this problem by calculating a maximum and a minimum of a function, because there is no function. This is the way an artisan would make a chair, just, a real, ancestral artisan. You make a chair, and if it breaks, you make another, and then you make another, and then you make another. But making and breaking an actual chair takes time and money. Making and breaking on the screen costs nothing. And so trial and error, which is a very stupid strategy in physical daily life, it is actually a very viable strategy when we do it on the screen. We can solve problems that way, which we could not solve in any traditional mathematical way. This is computational trial and error. So she was failing because that was what she was looking for. It was not a mistake.
Thank you, Mario. This is exactly, I totally agree. This is exactly what we are aiming for. And Brianna, in that sense, has been working insistently on that relationship. But I also think Cynthia was up to something else in relationship to that. And I think that one of the issues in general in New York and perhaps in Ivy League universities as well, is that the students, they kind of have like this intention of demonstrating how much they know. And that, I think, that blocks them from really entering into design research. And I think that what you're pointing out relative to simulation to me is very important, not only in terms of what's happening with statistic processes, computational design, automated design, and mechanic processes in themselves, right? In terms of setting up conditions, right? And learning from running the simulation. So thank you for the comment. I don't know if Sandra.
Can I jump in here?
Yes, exactly. Perfect.
Yeah, I would like to have a question. So thank you so much, Brianna, for your wonderful presentation. It's a great project. I just have one question from your outline. You're stating that before simulation software existed, architects could only rely on physical model making to test decisions, which could never reach the level of accuracy that simulations offer. That is a sentence that quite puzzles me, because I was thinking the other way around. Although we are using these beautiful computational models, they are still based on equations, right? So I think the physical complexity, I'm not sure if we can really capture that already. I mean, hopefully in the future, but at the moment we don't even know what is going on automatically with material and matter. So can you explain a bit what you meant with that?
Sure. Let me actually just go back to that because I didn't read it. Hold on. Nope, that's not it. Okay. So essentially what I meant by that, just based on the way that I was kind of conducting my research, I was trying to just kind of say that, really how amazing it was that we can, conduct these simulations when I had done some previous research, initially for like example, the shell, how it used like other ways that it was done, where there's like a method where there was like using a cloth to kind of represent how, I guess with physics, how it would fall over a surface potentially. And just overall, when I was researching the different type of simulations to see what kind of simulation I was going to be interested in kind of focusing on, it was just interesting looking back at kind of the way that different models were created. And, I obviously only did 3D printing models for the most part of this past semester, when normally I would always do by hand, even if it was with a laser cutter. It was very different for me. And so that's kind of what I was trying to explain with this, that like, obviously this is new technology that we didn't have before, whether it's entirely accurate, obviously with mathematical equations, we hope, yes. But I understand what you're saying, that it could be more or less seen as like kind of the opposite way, where I guess the old way is, obviously still a way to do it. Like I'm not saying it's wrong, if that's what you're asking.
No, I think I'm really curious how this will continue, this research. I hope you continue in this round, because it's very interesting. And specifically when you start using computational tools, you know, and how they interact with matter, with environmental forces, how they're starting to inform your models and your design. I think that's so enriching. That sometimes that's something that I could never have modeled in a simulation process. For example, just with a simple, very homogeneous material like plastic, there is so much more information when you start opening. For example, my students could tell if we open the fab lab doors, you know, when the cold wind would come in, the model would totally react to these circumstances. So I think that's and I congratulate you also to the monster. I love it. I hope you find a sponsor to get enough materials, not need to optimize, but really more to emphasize what you're looking for as a designer.
Right.
Maider, you want to say anything? No? Okay. You're muted, Maider, if you...
Okay.
No? Okay.
Hello.
Yes.
Okay. Yeah, I thought I was not supposed to talk in this one, but yeah, I'm happy. I also wanted to congratulate Brianna, especially because of this sort of experimental attitude to the problem, like taking the, as Pablo addressed at the beginning, like the computational strategies and questioning them and testing them and looking for, you know, having an open mind about the outputs you could get. I also appreciate this kind of intuition that she had at the beginning on kind of the idea of the water runoff. This is something actually that we often discussed about during my thesis work. I don't know whether you are familiar with the constructal law, the idea that, you know, the force fields and the water flow fields, you know, follows similar principles, and how you could actually look into them through very similar analytical approaches. So I think there is a phenomenological linkage there that can be, you know, that is very, very powerful. And at the same time, it can help you design the formal outcome of the object itself. So the whole theory talks about how you can, you know, manipulate, you know, those paths, those force flow paths or water flow fields, and, you know, adjust the geometry in this case to, you know, talk about these environmental or phenomena or force field phenomena. So I was wondering how you were, instead of like, it seemed to be that you finished your experiments too early in a way. You know, you say, okay, it doesn't work, but then what should I do to make it work? Or why doesn't it really translate into a continuous force field? Do I need to change the geometry so that it really, you know, the continuity of the forces does happen, right? How, like reevaluating that outcome based on that initial hypothesis, you know, makes you, you know, work on so that the next experiment builds up on the previous one, right? So while maybe that sometimes you have to say my initial intuition was wrong, other times you really have to adjust your, you know, that hypothesis incrementally so that it builds up on your initial intuition, right? So while I wanted to congratulate on this kind of attitude for this experimental attitude to the problem, I also wanted to highlight that, you know, sometimes you really have to believe in your initial intuition and say, maybe I really have to adjust this geometry and do these other transformations to the design so that I can make it work based on my initial hypothesis, in this case, making that water runoff algorithm work in your benefit, right? So geometry and force field come together. So you can change the geometry to make the force field or the water flow work structurally.
Well, that's exactly the reason why we were working that way, because you know, I've been working since 1998 actually in fluid dynamic simulation in terms of water flows, but the idea is to try to understand these algorithms in relationship to architecture making. So I totally agree, Maider. In some cases, I think it was difficult for the student to understand that, but I think Brianna did a good job in relating, trying to cross-relate one with the other, structure and water, right? So that was exactly the idea. So I'm glad that you see that as a potential in the project. Does anybody wants to make a comment? I feel like I need to moderate because so many people, but Alessandro, we are leaving you behind a little bit. We are joined by Galia. Alessandro, if you want to say anything in relationship to, perhaps a comment in relationship to the installation in itself, similar to what Cynthia was pointing out, right? But feel free.
Yeah, well, can you hear me?
Yes.
Yeah, no, right. Thank you very much. This was quite impressive. I would like to say something. My comments will be more following up to what Mario Carpo was saying. That was, for me, particularly interesting regarding the fact a series of terms that the students have used that for me have been very fascinating. One term was about manipulation, another term was about failure, another one was about monster. So for me, this is very interesting because these are terms that you frequently use exactly the same term in biology of evolution. There is a series, long literature from Stephen Jay Gould to Francois Jacob, explaining us how, in a way, our brain processes the information in a manipulative way, especially we don't have a scope. And this is why I like very much when Mario said we do think not because we need, but because we can. Actually, this is the power of evolution, let's say the biological power of evolution this way. So we have, as architects, many times we are so stressed that we need to have a deterministic goal to do things we call function, but which the terms function has a completely different meaning than that we're expecting in, let's say, in sciences like biology or evolution. So what I'm trying to say is that what I've seen here is a perfect representation of what in biology we could call exaptation. And I always find very interesting the fact that exaptation has not been frequently used in architecture, because the metaphor that usually biologists use for these as a proof of this process is spandrel, and this derived from the let's say from Gothic architecture. And when I was watching the drawings, I saw so many spandrels, so many expression of neuronal connection trying to develop something. And again, these give me this, I don't know, I was reflecting on the fact that another thing that this process is doing, so beyond being archaic, if you want, because I'm talking about the fact that we are doing something very archaic, not very highly technological and deterministic. I'm doing archaic in a positive way in this case. What we are also doing is also including, Brianna was talking a lot about the swarm behavior, if understood well. So, which I don't know, but one question would be, what were you using for agent-based modeling? What kind of software, Brianna?
Software, it's Grasshopper, the software is Grasshopper.
We're using algorithms and
agent-based modeling, have you used QLayer or something like this?
No, we are like, yeah.
Grasshopper for agent-based model. No, well, of course, because as Pablo said, the software, if you use QLayer, Grasshopper, if you use MailScript, of course, you have a limited range of possibilities in one or the other direction. However, what I wanted to highlight is the fact that, so what we are doing now, the shift is the one that we are, if I understood correctly what Mario Carpo said, is from this 2D to a 3D. But the reason why for me the swarm behavior is very important, agent-based modeling, is because in this final product we are adding a time frame which is visible through failure, and the failure are exactly the process of the spandrel, how they fail, but the rhythm of the frame, that give me the idea that this aspect is also part of this paradigm, new paradigm. So the fact that when we freeze an image, what we are freezing is a three-dimensional. We are producing this, but actually we are also producing this dynamicity of the processes of the swarm behavior that become visible, immediately visible. One last question, Brianna. So maybe you said, but I could not hear very well. How because of the process at the end, how you are imagining to print this? What are the processes? What material? What kind of machine?
Okay, so in terms of the full installation, we were thinking of going with obviously 3D printing, using a 3D printer. And while I didn't do it for the final version, I had a previous version that showed basically how we would section off, obviously, because we don't have a 3D printer that's incredibly large, but essentially section it off, but based on structural, so that we can be able to kind of essentially glue the pieces together and have them fit into place without needing any additional joints.
So you have,
Brianna, do you have
many pieces?
Sorry, what?
Brianna, do you have an industrial robotic arm?
You know, unfortunately, because of the pandemic, also the Fab Lab started being renovated because Maria got a grant to expand the Fab Lab. So we were had many limitations, but ideally the studio, the objective of the studio was for the students to build up their own machine for construction, but we did not have anybody dedicated to that, unfortunately. So then we lowered the scope to build it by parts, and then the pandemic happened, right? So all these things happen in between.
Yeah, but the good thing about digital production would be actually if you were in a situation professionally, you would just find a facility nearby and print it with an industrial arm that you can find there, right? You just send over the tool path and then just print it. So I think there is no, I think you should just think about printing it monococcally. So it's starting to capture some moments of the initial shell structure, because you're having a shell structure, minimal surface, breaking this into parts it's really a difficult step in my mind.
Yeah, in this case, exactly because of the flow, right? You would break out the flow. So I agree. But anyways, so thank you for your comments. Actually, Alessandro brought up a very interesting problem about evolutive design. And we're actually, some of the simulations that we're going to see later on, there are simulations that they are evolutive agent-based simulations. So more specifically, that is going to be touched. So, but I think that you brought up a very important issue, which is why we are doing what we are doing today and what's the relevant technology and how can we, what is our relative agency in relationship to that technology, and how can we expand that technology in terms of what we are doing, which is a little bit objective. But if there are no more comments, perhaps we continue, since we're getting a little bit delay. We're going to hear first Peter and then Alex that are going to present together. So Peter, do a fast presentation if you can, and then Alex takes over. And then we discuss both projects together. Peter, you're presenting.
Yes. Can everyone hear me?
Yes. Yes, go ahead.
Hello, everyone. My name is Peter Leonardi. So my title for the thesis was Structural Typologies. So when I started this, I wanted to look into all the different structural typologies that there were and let the forces enacting on the objects actually create the architecture without taking away from it. Because, you know, in a lot of cases, you have, it's not loading. You have, you know, you have architecture and then structure is something secondary that's added. So my goal was to try and combine these two ideas. I started with a lot of physical materials with manipulation of them. These are a few photos showing the complete models that were pinned up at school. I started with a lot of physical models. I broke them into 3 different categories of surface manipulation, A lot of them were friction formed, and then I finally ended with some tensegrity models.
For some reason, the screen is all fragmented, Peter. I think that the connection speed is the problem.
You should use the computer instead of the iPad. I know you were having issues. Present.
Yeah, you're using the iPad.
To your iPad.
All right, let's continue, Peter, and we see what we can see, and then Alex presents. All right, because in any case, Alex is building up on the structures. All right.
Yes. Let me try and go to a different part of my house, maybe. Is it loading any better right now or no?
I think it's the same.
Okay.
Just change slides, yeah.
So I tried to start with a lot of physical studies, the first few.
Now it's better, yeah.
Okay, I'm gonna stay where I am then. I really apologize for that, guys. The first one was truss and arch and inverted surface. So I was taking planes and bending them to create new surfaces, and the deflection was creating the form. And the same thing happened with the inverted surface. I was able to insert something into the surface, creating a new surface on both sides with the tension in the center. And then I started with tension forming. So I was able to compress pieces of wood together to create arcs that formed on both sides. And then I was able to stack some of these to become more structurally. I then went into another set, which was all about inserting and splitting. So the first one, I was splitting the wood and inserting members into it to create more surface area that was expanding them to deform the material. So, you know, the force acting on the object was deforming them. And then I did the same thing, but had the extrusions popping out instead of acting flush on them. Then I went into trying to work with more of a column due to the installation. So I took long members and was able to split them to create more surface. This allowed the forces enacting on them to actually put them together. These are all done without glue, specifically the friction connections. It was all held together specifically with friction. Then I went into some tensegrity. So these were all formed by the tension of the members connected, and then the load pushing down on the object would change the shape of the column, whether it was the diameter or the height. So they would all vary depending on how everything was enacted on them. Then I started to translate it into simulations. I tested the iterations and connected them to help understand how the material interacts with itself and within the connections. Working with mechanical and non-mechanical connections gave a variety of outcomes varying between surface area, strength, and structural rigidity. So I did this with 3D printing connections. I worked with Brianna Lopez, as you just saw before. We tried to take her shell and break it into parts, as she said, to figure out the best way to assemble it when we went to Venice, because it was one of the biggest pieces and most important. The shell structure is here, as you saw before. So I was able to test a number of adhesives and a number of joints. We found that a no joint, simply just a butt joint, was the best way to connect it, and that plastic weld was the best because all of the other adhesives actually damage the surrounding area. So this was the best one that kind of held everything together without actually damaging the cell structure. Then we went into trying to find the most optimal way of assembling one of her shells, because we would have to be bringing it to Venice in parts. So I began to work with the one that she showed before. I was able to 3D print it at home and assemble it in parts, and then it was put together.
Now she's getting the hang of it.
So after I assembled the 3D model, I tried to translate some of her shells into virtual reality, because now that we weren't going to Venice, the next best thing was to show experiential in a virtual setting. So I was able to create 2 of her shells in a virtual reality software seen here. And that's pretty much how we kind of tied it up at the end.
All right, Alex, if you can continue. Thank you, Peter.
Okay. All right, I'm going to share my screen.
It's so amazing how my internet died at the worst moment.
Okay. Hello, my name is Alexandra Pannichela, and my project is titled Material Translations, the Feedback Between the Analog and the Digital. The project opens an inquiry and conversation about the material relationship between the analog and the digital. The first part of this inquiry began with the physical fabrication. Here I experimented with the properties of wood, chosen due to its significant use in nautical construction in Venice, through techniques of bending along the material grain and connecting pieces. The form evolved into a self-supporting structural system. So the beginning manipulations include techniques of etching, cutting, and carving, soaking and bending, and then darting with paper and thin plywood. Advancing from the wood manipulations to a self-supporting system, I created a volumetric framework to operate within. The framework contains iterations of volume, surface, and line. These iterations then combine to create a larger system, and through changing the system's parameters, multiple columns emerged, expressing notions of transparency. The next part of this inquiry is the digital fabrication. This involves taking the physical properties of wood and applying it to a digital workflow. The natural properties of wood are translated literally and/or conceptually through the lens of strength and tension. This includes the replication or rearrangement of the material grain of wood to the immaterial grain of PLA according to its strength. So in order to define and manipulate a material and immaterial grain, I deconstructed a simple surface model into its G code. The code consists of X, Y, and Z coordinates, which direct the movement of the 3D printer. The Z coordinate is responsible for defining the layer height and, as a result, the grain. So this simulation just shows a multitude of grain densities that is achieved by manipulating the Z coordinate in the G code. So as it grows, you can see how the densities are changing. The study is developed into 2 types of grain manipulation. These include the contour and the wireframe, where the manipulation of the Z coordinate created different levels of transparency. And these were accompanied model photos of those. Oh, okay. The final portion involves the combining of the feedback of the digital and the physical into a final proposal to be incorporated in the installation space. The design was informed by the physical fabrication and converted into the digital workspace. The digital studies of grain manipulations were applied to all the elements of the final form through wireframe and contour variations. These show the change of densities from low to high and a combination of all. So these ones were wireframe. These are the contour variations, and then it gets applied to the final form. So in order to arrange the grain according to its strength, the form was tested in a structural simulation. And as a result, this is the combination of wireframe and contour densities that create a self-supporting system. And this is like a synopsis of the whole assembly, I guess. Thank you.
Right, thank you. If now Sandra Mai Dragalia, if you want to make any comment. There is a cat there.
Maybe I start if
yes, yeah, go ahead,
yeah.
Maida.
So to Alexandra, if I pronounce it correctly, congratulations. I think it's a very interesting project. I'm particularly interested in the exploration of anisotropic materials, which is the case with wood, for example. And I think it's a challenge, really, what you addressed already as a question, like how you transition and how do you feedback between the analog and the digital fabrication process, particularly for these materials, right? That are often like the materials that engineers don't like because it's unclear what the mechanical behavior is going to be, right? For me, there are two interesting moments in your project. I really like how you talk about the micro and the macro simultaneously, because they are definitely key for this kind of particular materials, like cellular type of materials or anisotropic materials in general. And how you talk about the digital fabrication process in relation to this. And I would also wanted to ask you, because for anisotropic materials, apart from the kind of the construction of the material process itself, another important aspect is the boundary conditions that is affecting that given structure. You know, wood is more sensitive to environmental changes, changes in loading conditions, changes in humidity, you know, you name it, much more than, you know, an homogeneous material construct. So that would be another interesting ingredient to bring into the game if you really are interested in looking into or deeper into anisotropic materials, right? One thing is the inner construction of the material and the mechanical behavior that is also anisotropic, but also how do you talk about or how do you incorporate in that design the boundary conditions and how they are going to shape your design, in this case for the pavilion.
So should I pose a question or?
Yes, please.
Oh, right. Now that you changed your strategy from wood to FDM modeling procedure, so how would you envision the installation to be installed in Venice?
In terms of whether it would be, like, if my fragment would be made of wood or PLA?
What are you exactly? What would be your preferred material now that it's extended for a year?
My preferred material would be the wood, but I think the exploration with the PLA filament allowed me to really push this experiment and change the whole fragment in a very different way than I would have anticipated. So,
did you 3D print also the small pieces that we see now? Or
yeah, I have a model photo.
You have the different fragments and the small pieces and the bigger pieces, right?
All right.
I have this model photo, yeah, and then I have little pieces, but
because it seems that you have tackled the worst case, which is really this long, almost 90-degree angled surfaces that are really hard to print. So now you know probably for the next step you probably might want to turn it like 90 degrees. And
that's what we're looking at, exactly.
Yeah, that one was printed horizontally, actually.
Yeah,
because the fiber, the question is what happens with the direction.
Exactly.
Yeah.
But there's really methods. I mean, sometimes it's really good to position a model diagonally. So you're under a 30, 45-degree angle. It's really depending on the tool you're working with and the materials. But I really appreciate it. But I'm really interested in how you would conduct it in, the columns are very elegant. Would you go back to columns, or would you just translate this design now into a wooden structure?
I think it would be the bigger structure. Are you talking about like these columns or
the ones that you did before the? I was thinking really the columns.
Oh, from last semester?
Mm-hmm.
Oh, okay. So these ones.
Yes.
Yeah, those were.
I mean, these are very beautiful, elegant designs. I was just wondering whether this could be a strategy how to agglomerate to bigger installations.
Yeah, I mean.
Yeah. Go ahead.
Sorry, these were 8 feet tall. These ones here, so they were full scale. Yeah, I think just complications with the pandemic and the.
Also, the CNC, our CNC closed, so we also had to change. We were going to do a CNC model, and then we had to change. So it was funny how everything became like that. But the other interesting thing was Alex looked at also for a moment at PLA, wood PLA. So we were looking at those things. It's very various issues in terms of the process. But independently from the technical aspect, I think that the project has many interesting issues that is raising. Cynthia, you want to say something?
Yeah, I did. You can see that I unmuted.
Exactly.
Again, since I'm not a technical person, I have different questions about this for both Peter and Alex, and I think it relates to Brianna, which is that ultimately you all had to make a final object to be on display. And am I right that there was going to be a fit? We're talking a lot about material and construction and process here, all of which is very well argued and presented. But I'm also thinking about the installation itself. So I'm looking at these final objects, and I thought it was quite, to me, there seemed to be in both Brianna and Alex's work a kind of anamorphic character that begins to occur, and I wonder how that comes about. Less so here in this column, Alex, more so in your arced structure, where these angles that I'm sorry, I don't know your name because you're showing up as Sam on your window, where she's saying, how can you make those angles? I'm looking at those angles and thinking they look like the joints in the legs of gazelles or something. I mean, that have started to actually look at how animal joints went together, you could figure out how to actually 3D print this or mill it or whatever, right, to build it, whatever these processes are. But my question was whether that was intentional. And then for Peter, whose objects were really quite beautiful, and when you took these sort of structural typologies and exerted these forces on them, for me, they lost their structural quality and really became quite sculptural, and which obviously you would want to put on display in some way. So I was interested if that, am I just reading that into this, or was that an ambition, or is it just purely an experiment? is all of this purely an experiment? Its results are quite spectacular.
In the beginning, you can go first, Alex. I'm sorry.
No, go ahead.
Oh, Peter, yeah.
I was just gonna say, yes, in the beginning, I wanted them to turn out to be a little more sculptural because the architecture and the structure was supposed to be combined. So having those two come together instead of having, like I said, you know, architecture on one end and then you have supports on the other end, like kind of having a mesh would be good. But I didn't want it to be sculptural in a sense because then it would just be like, I think more decorative, like not serving a purpose. And like I wanted it to serve a purpose and like still stand for what it was that it originally was when it was made. So I definitely want, like in the beginning, I was kind of on the border of like, is it sculptural, is it architectural? And I really tried to kind of keep it architectural.
Yeah, and I think for mine, like in your comment about how it looks kind of like anamorphous, it wasn't intentional, but I did start to realize, like as it was like being generated, that to me it looked kind of like skeletal in a way. So that was just kind of an accident that happened.
Well, to me, it's an interesting question what Cynthia, you're pointing out, because this is truly transformative, both structurally and in terms of how the structure is working, but also the relation between point contact, line, and surface, right, and the rotation. So that's to me the most interesting quality of the structure, that the structure and the meaning of the structure changes in relationship to its performance. And that was due a little bit to the investigation of the wood. And now Alex is looking at a different technology to see what survives of the previous idea and what is transformed to overcome the material. To me, the relationship between working strictly with a material as a technique problem and shifting into a 3D printing abstract problem was also part of the agenda, to not fall into a kind of technicality and to understand what is a little bit the agenda, the architectural agenda in relationship to technology, and try to invert back and forth one and the other. And if you guys notice that the installation goes from the space being contained, positive and negative, as it progresses and it pushes to the sides to activate the perspectival view. So that's one of the ideas. But I don't know if Galia and Fred have any comments. Otherwise, we go to the next one because we're running a little bit late.
I have a short comment. I
very
think
good
that,
comments, by the way. Yeah, Galia, go ahead.
I think that these two projects that I just saw really address your premise of the interscalar fluidity, in the sense that you start with a problem that is a structural problem and material that is wood, but it's highly processed wood. It's not wood that you find in nature. It's wood that has been pressed, dry, stretched, bleached. And so it's not wood, it's not natural wood, it's processed for construction, for model construction wood. And you end up with something that goes, and I think this issue that Cynthia brings up of whether it's a sculptural or animal-like, and it does have, in both cases, a bit of a gazelle or a bit of a neck of a bird or a beak of a bird scale or form, depending on what scale you look at. And I think it's this ambition or this mission of animals. You know, there's a bit of biophilic affinity here, in the sense that animals try to be the base structure they can be for the lightest purpose, and they try to be light and not break. And so that your structures are almost doing the same. They try to be as light as possible. And so they are kind of, that's what I think what we tend to see in where we see the sculptural, because they're so almost at the breaking point that they show elegance. They show, especially these images that are now in the screen of Alexander, they show this kind of elegance and lightness an ambition to be tall, to be slender. And those are, they come from a structure, but they end in the sculptural, which I think it's a very good place to be. And it's architectural, and it's at the same time, it's not. At the same time is almost the ambition of an animal.
Yeah,
Fred?
If I may join in the similar thing, I was having those questions more regarding Brianna almost, which would be the rigor of the parameter. I mean, as much as there were lots of really interesting exploration, it was difficult to know if it was based on gravity or on kind of a self-similar system of abstract element. And here, maybe Alexandra and John were more precise in saying, well, we're going to look at how the physical impact virtual. But I think being as, I mean, and you're looking for kind of unexpected condition, and you're looking for potential misreading or a potential deviation or element to sculpt or to generate new things. But I really think if you would be clearer with what's the aim or what's the condition or what's the parameter, I think it would be maybe easier to extrapolate, to understand the next step. I really like the comment of maybe looking at the problem that you find in wood. If you take a real piece of wood and you would have, let's say, a knot, that will bring you to a divergence or to a new connection. But so it would be interesting for me to see more precisely what do you privilege. If it's a look, if it's the, I mean, there are a lot of parameter.
Thank you, Fred, and thank you, Galia. Great comments. If anybody wants to make a short comment, otherwise we go to Ari. No? All right. Okay, Ari, go ahead.
Okay. My name is Ari Bigan, and for my thesis, the title is called Spatially Interactive Light. And starting off, the idea behind the interactivity, the idea behind the thesis is that we want to engage the users within the space, the individuals within the space, that they feel as if they're a part of the thesis, and therefore they want to stay more. Could be that they'll want to invite other people because they feel as if they're part of it, because they're interacting, whether it be with the sensors, could be through their phone, could be through other types of input. And working with interactivity, you can have a physical button, you can have something which is more virtual, which could be on a phone acting as a virtual button. Or in our case as well, we have the ultrasonic sensor. And through the use of the ultrasonic sensor, it captures the distance an object is in relation to it. And depending on the input, it can output various results, whether it be a color of an LED in this case. And over here we see that based on the distance of this object, the LED light is changing according to the input of the ultrasonic sensor. Continuing further, bringing the ultrasonic sensor a little bit into the lighting model, is we have a mass lighting model in which over here the hand of the user, as it gets closer to the hidden ultrasonic sensor, as we'll see in the video, then the light flow is actually, it goes slower. So right now the light is flowing throughout the model, and as the hand gets closer, the light slows down based on the input from the ultrasonic sensor. Continuing further is just some of the photos taken of the model. And over here, you can actually see a front view of the hidden ultrasonic sensor with the LED light within the massing model. Just a quick video as well. So you see as the light flows throughout and the sensor is hidden on the bottom. Continuing on, we actually have, I was working a little bit with my classmate Isaiah. He was working with the interactivity of sound. And over here you can see he's actually using He's trying to capture the ultrasonic waves that are coming out from the sensor and to sort of measure the frequency that's occurring at that time. Continuing further, going a little more into the lighting, putting interactivity a little on the side, focusing on different types of light. We have point lighting, what happens when the light reaches a corner, what happens when it reaches a curve, so on and so forth in some of the 3D models. And then working a little closely more with linear lighting conditions, whether it be in color in this case, and over here. And then what happens when we put a point light within a linear straight fixture? What happens when you add 2 points? What happens when you take these points and you move them further apart? What are the effects that the lighting will bring out? And some of the iterations that I went through in this linear fixture. What happens when you take a linear fixture and you curve it? And the same experiments as we did before. What happens when the linear fixture is closed on one end and then it starts opening toward the other end? The light is splaying outward. And some of the iterations, and then some of the 3D models on the actual computer simulating such an effect. And then the question is, what happens when you combine all of these lighting effects that we saw previously and we get this? Just a live model of such a collaboration of lighting conditions, and then working with more of spatial light. How can light create space? How can light create space that before would never have been perceived, would never have been, so to say, existed, or at least in the perception of the eye? Continuing further with just some of the study models, and then working more with ambient light. What happens when you reveal edges within the ambient light? What are the various effects that you receive? What happens when you reveal a corner, the distance of the corner that you reveal, and just some of the close-ups that we're dealing with. Then working further into more of the integrated installation, working with classmate of mine, Ben. He had a part of his installation, seeing what are the effects that the lighting will have on such a surface of the installation, then looking at point lighting conditions that a user can expect, linear lighting conditions, and then working with on a larger scale of a fixture. So over here we have what exactly would the light possibly look like within such a fixture, as can be seen in the animating effect of the video over here, where the light is changing, and then also the light is, it's not just changing light, but it's not just changing color, but it's also reacting in distance as well. Then working further with bringing back the ultrasonic sensor we saw earlier with the larger linear fixture. How would that come into play possibly? So as the user gets closer to the fixture, the light would be diminished more and more. And then continuing further, working on ambient lighting with color. So over here, you're looking at the light, the linear light directly. What are the effects that it has on the surface around it? What are the effects it has on the surface behind it? Some of the close-ups. And then working with edge linear lighting. What happens when the light goes further in space, and then until you reach the actual perspectile, the point, the vanishing point. And then working within the confines of the room, what could be possible iterations that you can find within such a space. So starting off with the volumetric lighting, working with a linear light, surface lighting secondary, and then third is a linear lighting, and lastly is the point at the end of the room. Then going towards the group installation, over here, how would this technically play out is an electrical plan of where the lighting would be specified within the room, the exploded axonometric of my classmates, and how would the lighting go in collaboration with such a room. So working with the various lighting conditions, we have the fragment number 2. That would be represented in a way of an edge linear lighting condition, such as the following. Then working with the other fragments, more of a column lighting, that would be represented with a column linear light. And then getting into the actual space itself, we are working with a perspective. And that would play out with, I guess, here are some of the possible variations that you would see within the actual perspectile view within the space. So over here, everything's focused on the perspective view. It's all going towards the vanishing point and just playing with the different animations that could be possible. It's endless, but here's just some. And the effects, they would be all based on the input that would be coming either from a user with their phone, could be a physical button. In our case, mainly with the ultrasonic sensor based on the distance of a user, or depending on the distance of multiple users within the space. So it would change accordingly to the input. And then continuing on, bringing back the ultrasonic sensor with the edge linear lighting condition, a larger scale. So you have the user as they come towards the linear lighting, they come closer to the fixture, the lighting is reacting accordingly. So the blue lighting over here is getting smaller, as the user comes closer, ultimately to a point of the blue light. And then working with some other iterations where over here we have the user comes towards the end point, the vanishing point, and over here there's two sides that are rotating in the linear light, and ultimately as the user gets to the end, it all becomes a point condition. And lastly is where the user is walking towards the vanishing point, and all the sides are taken into account, and each of the linear lights, they get smaller and smaller, ultimately until the vanishing point to a point condition of light.
Okay, that's it, right? Thank you,
you.
Ari. Ari made a kind of mock-up of the installation at his home, right? Because of all the crises that we're going through.
As much as physically possible.
Cynthia, I know that you have to go. You want to make any comment before you go, or?
Yes, I will quickly say something. I want to make sure I understand this. This is a fascinating presentation on lighting. It seems to me, Ari, you have a career ahead of you as a lighting designer. What, Pablo?
Yeah, we don't know if that is a blessing or not, right?
Well, no, my question was, I want to be sure I understand. When you were showing the lighting patterns and moving toward it, is this in the same space as your classmates' physical objects, or is it in the other room?
So that's a very good question. The way it actually turned out was that being that the Venice Biennale was delayed, and we were working more towards a virtual reality. So we knew that the physical space couldn't be occupied. So the idea was to represent the columns of my classmates with the linear lighting conditions representing their physical columns. And then in the virtual world, you would see the physical columns overlaid on the lighting conditions within the actual space.
Originally, let me clarify. Originally,
no, I followed that. That makes sense, because I was thinking that if that were occurring in the actual physical space, wouldn't the lighting design overwhelm the physical object? I was wondering about that relationship, but how is he? That's why I asked the question, because you want me to talk about what is the effect of the installation, right? And that makes total sense then. Okay.
Originally, I have to clarify, originally, yes, the lights were going to be inside the columns and within the space and so on. And then we redesigned in order to make, because we had to start making compromises in terms of the fact that the students were not going to be able to travel, right? And then we started activating a mixed type of reality, which then we're going to introduce in the, Ben is actually in the next presentation, he's going to show the entire installation altogether as a VR model. In which there is a kind of mixed condition between one and the other. But yes.
Well, thank you for having me. It's all really intelligent work. It's been great to be part of this discussion. So good luck. Thank you.
Cynthia. And hopefully we get you engaged when we present this in Venice, whenever it happens.
Yeah, good idea.
Thank you. So here is supposed to be Fred and Sandra, Maider, anybody? Or
I'm not sure why you put me in regard to light.
I don't know
I'm
either.
not a big specialist of light. Well, I mean, I appreciate the experimentation that you are really.
It's cutting, or it's only me?
Yeah. Also here.
Okay, so maybe
Yeah.
Maider, you wanted to say something?
Yeah, I wanted to congratulate. It's a very interesting work, I think. And I mean, the question of interactivity is very complex. So I wanted to ask you how, because right now, as I understand it, at least somebody enters the space, and depending on the distance, the lighting conditions change. And I'm wondering whether if you want to change how that occupant or occupants feel in that space, are you thinking about how you're going to maybe learn from those, you know, reactions or those experiences that may vary between the visitors, or may vary depending on how the lighting conditions are changing, and whether that could be maybe incorporated within your lighting strategies? I very much like the studies on the point, linear lighting, and the effects these are creating. So how those are giving different feelings or different reactions, if you like. So how could you, incorporate those back so that the interaction is not only passive, so I don't only enter the space and by entering this happens, but how I react, maybe it's informing what's going to happen next in a way. So I wanted to ask you about your thoughts.
Yeah, for sure. I definitely agree. And I think it would be amazing for actually the same person to come into the same space and to have a totally different environment around them because he came at a different time, or she came, a few days later, or they came with other people. So I definitely think working like this is not an ending. It's always just a beginning, at least in my eye. So just working towards actually probably incorporating cameras and to have that tracking people, so you can, or it could be multiple sensors depending on the types of input that you want to use, so that there's no same experience for any person. And because of that, the space would be changed, whether it be the lighting conditions, whether it be linear, volumetric, or surface lighting. And for sure, I definitely think that there's definitely room to play with the variation even of the same person within the space.
Fred, sorry, you were cutting. You want to say something now?
Yes, I think the perception, or the perspective, or the illusion of space that you can offer through, let's say, a visual space into a physical space, and that kind of ambiguity between 2D space, 3D space, in that sense, kind of a virtual space, because you imagine in your mind what is the space, is something you could explore a bit more. I mean, you did create those accelerated perspective like Borromini. I would suggest you look at the work of somebody like Felice Varini. Do you know his work?
I've heard the name. I haven't looked much into.
but you could create shapes or create space that exist only visually or that are in combination with the physical space. In fact, what you could be doing, instead of reinforcing the visual Borromini one-point perspective, it could be off-center. It could be a different perspective that you could overlay on top of the physical perspective that is actually built. I mean, you have more freedom to play with light than with actual sculpted or built element. And I'm not sure you're fully taking the advantage of that.
That's exactly, I think, the point, in a way, to work with a mixed relationship between representation and acting of representation, displacement of the system of representation, and reactivating of a different type of reality. So I'm very happy that you're bringing that up, because the target is specifically that. The students, you know, as you can tell, they started understanding the principles of representation in terms of projection to space. So they are a little bit like starting to understand what they can do with it, but eventually that's the objective.
Well, that's why I'm bringing in Felice Varini, who kind of reversed the hierarchy, was the visual space imprinted itself hierarchically over the physical space. So you could visually create, let's say, a funnel space that doesn't exist physically, but exists visually.
Exactly. No, I totally agree. Thanks, Fred, for bringing that up. Sandra, you want to make any comments?
Yeah, absolutely. A very beautiful project, and it's very elegant. I think I really appreciate how minimal you're working. I agree totally with Mader that your studies in point and the different light situation is something that is very valuable. My question would be, could you imagine that the light is starting more to scanning the space and the sculptures within than just reacting to people? So probably start to help, help understanding space better, or probably highlighting some features of your colleagues' designs. So they're starting to communicate in a totally different way, in a totally different sense. And then I again agree with Mader again, because they can learn from each other. So these systems can start something new without the human interaction.
You're talking about actually what the other students are doing in terms of simulation with the algorithms to happen at the level of the lighting processing. We were discussing that also with sound, but it's not only, to me, what was interesting about the students is that independently from the technical expertise or not, they actually, is the first time that they're working with these systems. To me, it was more actually a conceptual problem, as you were pointing out, Sandra. Which interested me, right? That in reality, perhaps today, the limit is not so much in the technology, but in what we think. And for some reason, lately, the last years, the students are, perhaps, as the technology becomes more accessible, the concepts become more recessed, right? There is a kind of interesting negative feedback in terms of the spread of information. And I want to make sure that we keep a minimum level of intelligence relative to that. Somebody is relative to that. Yes. So there was an echo. But if you don't mind, since we're running late and the reviewers for the second turn are starting to come up, we are going to have Ben present a little bit of the synthesis of the installation. And then we're going to take a 5-minute break, and then I introduce the new reviewers that are joining. Unless somebody has a specific short comment, we jump to Ben. No? All right, perfect. Ben, yeah.
Yeah, and I just want to say I'm going to be presenting the group installation, but of course there's drawings from everyone's work. So I don't know if some of the critics came in late, so nevertheless things are going to be discussed about the drawings in relation to the installation and how it all kind of works together. So,
in other words, we're going to repeat this presentation after for the reviewers that are coming in now.
Yeah, so there might be a bit of repetition, so we'll move through some of them quickly. And I'm also going to share computer sound. Okay. You guys can see everything? Looks good?
Yes.
All right, so the group installation, the consolidation of all of our kind of fragments. So just as a kind of general overview, the kind of the fragments were organized and trying to consolidate the varying methods of simulation, whether it be water flow, CA, which is what, you know, or growth-based systems, lighting, kind of, you know, all umbrellaed under simulation. Moving through the first kind of fragments, or moving to the perspective that kind of binds it all together. Andreas's iconography in architecture. Andreas?
Oh, well,
yeah, just
I think it's better if one person presents.
Okay.
The idea is to that, because I think we don't have too much time. You want to say
okay.
something?
I just didn't
short,
want to
Andres?
misrepresent, you know, someone's work, but I can move through it if that's more beneficial.
I mean, unless it's very well choreographed. Andres, I'm sorry, I don't want to interrupt your ideas, but we don't have too much time. You want to say something fast, or?
No, Ben can continue.
Okay, that's fine. I'm sorry. Yeah, the kind of understanding of the perspective and the visual scale, and understanding how we can use perspective in relation to the fragments to start warping the visual effect within our room versus the neighboring room, and how we can adjust based on the levels of perception and the size of the fragments tapering towards infinity. You know, that right there, the kind of understanding of the physical and the digital, and the idea that, especially even more now, the installation has the lines of digital and physical have been even further blurred based on, you know, our current system. Kind of going through that kind of work, and now parametric flow and the work of kind of understanding how we can look at surfaces and the idea of simulating over them, and developing a series of fragments that are not only the work of one, but of two, and kind of looking at both structural-based work and simulation-based work and growth and stuff like that. Going through kind of work. One is going out. And kind of looking at possible iterations, whether it be agent-based modeling or group-based systems, or the kind of flow diagram, and which ones work more structurally, or develop its own kind of linear and branching language that works a little bit more with other people's research and development of that. My work was just based on CA, and I haven't gone through my presentation, so I just want to add a couple more. The discussion about growth-based systems and agent-based modeling, and specifically CA, and the kind of rule sets of certain kinds of cellular automation, and its zero-player game, and its level of initial states, as well as its idea of typography, and how important typography is in something where you can only affect the data collection at the initial state, and then the simulation grows, and you have to understand how you develop that information. You can kind of get an idea of how 1D CA can be expressed through a spatial system, as well as 2D, and how these rule sets can develop the level of density within the space, or at least the level of growth and activity based on simple tests. And the primary research, which was 2D over time, representing a two-dimensional collection of data in a three-dimensional way with the use of time, and then how it can possibly be reinterpreted both as a rigid as a rigid or fluid system, whether it be a closed surface, a minimal surface, or a skeletal wireframe based on its relation to porosity, to scale, and to use of material and physical fabrication. And then an animation of how those grow and how those will develop. And how the collection of data and then the increase of the surface to develop a series of relationships, and how that closed surface can be expressed as an open surface, and how that open surface can be expressed as a kind of optimized wireframe, as well as understanding how we possibly may be working with other fragments, and how swarm-based modeling can translate growth-based systems better with neighboring fragments, and how that could be reinterpreted less as its own individual form, but as a supplemental piece to someone else's surface, as well as how.
If you can speed up a little bit, Ben. Yeah.
Yeah, not a problem. Some reduced surfacing, and how that reduced surface can then be reduced and then understood as a kind of inhabitable space versus a framing space based on its own complexity. That surface itself, and how it is reduced as a kind of primary threshold to the perspective. And then structural optimization and those kind of typologies based on the research of a fellow student, and how those were fragmented within the presentation, and how that information is then adjusted based on research, the structural research. Again, researching structural topologies and its possible uses within the physical realm of the installation, as well as the beginning of like the branching of these different fragments of the installation, the kind of the one thing that kind of meshes, that kind of unites everything, the idea of simulation and this branching and reducing using structural optimization, whether it be a kind of wireframe to develop a minimal surface that can be looked at more as a kind of exoskeleton, similar to neighboring fragments, and a kind of typology, an initial typology that can be expressed physically, not only digitally, and then looking at the complexity increase by an initial state of typology, and then a development of emergence here, and then the growth to another typology that then simplifies and then becomes a level of stability past its own emergence, as well as its physical versus digital representation, how kind of large complex structures will then be reinterpreted physically rather than digitally, how the minimal surface then becomes cantilevered, and it's represented more of its kind of linear material truth, as well as this one, the same kind of idea, a certain initial state, a certain level of emergence, and then a typological stability, and then its representation in the physical realm based on certain real world limitations, and then the closing of the surface and a certain level of chaoticism, but it still holds the identity of typological markers there, and how that could be still kind of you know, developed through typology. And then the actual space, kind of understood through the perspective, the inclusion of the meshes, the fragments, the the increase of the room to begin manipulating even further how the space can be read, the inclusion of animation, how that space could start to experiment, and how we can express that digital realm, you know, whether it be through animation in the actual space, and whether it be a simple collection of data on the boundaries of that past installation part, you know, being represented in the real world through a projector that can be understood both in virtual reality and the physical realm through digital means. And I'm sorry for speeding up a bit, but
no, this part is fine because it's a group. So
okay. And then how how the animation can be represented in the digital through using the perspective grid developed by Andreas, and how that can be kind of expanded to infinity to express, you know, the constant path of the room.
Pablo, can you hear me?
yes, Carl.
Can I interject, because I don't see images, I only see people.
You have to blow up the viewer view. We are all watching, but if you change the viewer, the share screen, you would be able to see it.
Shift and what?
No, you have to change the viewer mode. Swap share screen video. I'll chat with you. Continue, Ben.
Okay.
Ben, continue.
Yeah, sorry. Okay. Still showing the animation and how that part of the room can be expressed through the digital realm in the actual installation by through an animation, and then looking at how some of these superimposed images can show a level of detail, whether it be the structural optimization information, the G code, superimposed on the mesh. Again, an idea of how that layering of information is important, as well as and I think we can move through this a little quicker because I don't think anyone hasn't seen it, the kind of understanding of how light can be understood through the perspective and the installation.
Carl, we're going to repeat this again in the second turn in any case.
Now it's showing.
Okay, cool.
Okay.
Yeah.
We're running late. This is a first turn review still.
Oh, really?
Yeah, we're running late.
Okay. As always, right?
Yeah.
Hi, Anthony.
I will introduce you all after, all right?
Okay. Who are the other critics?
Well, I'll introduce everybody after because I already introduced the first set of critics and we are overlapping.
Okay, all right. Because I hope that my internet won't drop.
Yeah. Ben, are you still presenting?
Yeah, no, I'm just, I can still.
Okay.
I guess I'm not sure which people are still here. The sonic and sensory. We can go through that a little slower just because kind of the same way we're using light in the virtual and physical realm to adjust the space. The same thing we're doing with sound and trying to develop a kind of soundscape for the installation done by Isaiah, and how in the perspective that sound can be both visualized with the eyes, not only with your ears, hearing it, both seeing it. It's, you know, contribution to the perspectile kind of, you know, tapering towards infinity. As well as the work on a thesis for involving humidity and temperature, and something Karina developed and researched based on the possibility of analyzing the structures through heat and thermal rays, so that, you know, we can understand possibly how 3D printing these can affect, or having these 3D prints around the in the installation, a hot, humid environment such as Venice, especially during the summer, how the heat can affect the kind of drooping of the 3D prints, and how we can possibly make sure they last longer, and make sure that the installation we install is the installation that exists in 6 months. So kind of imagery with that.
Why don't you show the VR? Okay, you want to share the link in the chat?
Yeah, sure. Let me,
so everybody the reviewers can navigate. If you open a browser with a link, you can navigate the model.
Yes.
It's going to take some time to load, and you're probably not going to be able to talk while it's loading. Can you copy paste the link?
Yeah, I'm just gonna grab it right now, and they can, I can copy and paste it right into the comments, I'm assuming, if I can find the little comment.
And the idea is that you can also navigate, obviously, with a cell phone.
Am I missing some? Where's the?
Just the chat. In the chat, just paste for everybody.
There you go.
Okay. All right, and now you take us through the navigation, right?
So I'm going to take through the kind of initial walkthrough of the existing space, kind of untainted, just a quick kind of walkthrough based on the neighboring space and how all these kind of pieces, and don't worry, I have other versions, so, and how the spaces will kind of be perceived normally, including the kind of past perspective, and then developing a series of kind of views that will then start warping the perception of how you can start experiencing both a varying focal, and as well as the inclusion of not only physical portions of it, but digital portions of it. So how the curtain can kind of come down, show the perspective, as well as the information that's been developed, not only decode, but the kind of swarm and the two-dimensional points, and how this space can kind of be understood, as well as a kind of manipulation of the possible focal point, and how that can be further distorted. And a kind of full walkthrough that I think is very interesting. It kind of shows how that whole space is kind of shown slowed down in a fully warped kind of idea, showing kind of the more interesting aspect, which I think is the kind of digital interpretation of these forms, not the kind of rigid idea of it, but the kind of digital interpretation of it. you can kind of get an idea of that. So people who actually could enter this installation could scan the QR code and then go through these walkthroughs and these different views that start to expand the focal length, and how they can understand how it's not only being manipulated through the physical realm using Andreas's perspective grid that we've adopted for the installation, but a kind of digital reinterpretation of the of it through VR, and how there's multiple ways we can begin to manipulate the perception of the viewer. I think with that, that's
right.
about it.
Okay, thank you. So the idea is the following. This is the end of the first turn review. So I would like the people that have been participating to make comments, and then we resume 5 minutes break, and then I introduce the new reviewers. All right. So just please be patient, or if you want, logging in like 10-15 minutes. All right. So Sandra, you're still there. Maider is there. Sandra, Maider. Alessandro, you're still there. Very patient. And Christian also came back. And I think I'm missing somebody. Fred. All right. So if you want to make any comments, perhaps you understand a little bit more clearly the relation between the part and the whole, because before we saw individual presentations, now they are all coming together here in terms of a mixed reality between construction G-code manipulation drawings and virtual navigation, virtual reality, but also a projected image. The animation part that Ben showed is actually going to be physically in the space. So the idea is that we start playing with different types of reality.
Probably I can start.
Yes.
It's just Andes, Brianna, Peter, Alex, and Adi, congratulations to such a wonderful presentation. I'm really happy I was part of this and could listen to your explaining your project. I'm also very excited for you that you could do this wonderful project for your undergrad thesis with Pablo, who set up a very interesting outline, and it's really amazing how elegantly you turned a very fabricated hands-on project into something that lives also in a computational realm in another reality in a very beautiful way. So I'm very happy to see these transitions also, and I hope you all enjoyed the process as I did enjoy watching it, your presentations, and I hope that you continue this research. Thank you so much for having me.
Thank you, Sandra, for your bright comments and your insightful comments. So thank you for participating.
Yeah, if I may jump in, I think it's really fascinating what you're doing, and maybe the fascination is also in its ambiguity between the virtual and the physical, between the visual, virtual, and physical. Where you take those paradoxes very creatively and you are playing with it.
Ben, sorry, Ben, can you change the view to the best view? Thanks.
Yeah.
Sorry, Fred. Yeah.
Yeah.
Always looking back. Yeah. Sorry,
Yeah.
Fred. Go ahead.
So, I mean, it's interesting because very much this kind of self-similar system of production of a new system of organization, but then it's to be experienced by the body, it's to be experienced in space as an installation, it's to be experienced physically and visually, so point of view, perspective, so you're mixing a lot of things which to my point of view are still not perfectly clear which one you prioritize or how you work with it, but that's where also it's interesting, is that you are making possible reading, possible interpretation, and actual things, or things that are about its own manufacture, or things that are about its perception, but things that are what they are. So I think you're touching a lot of that realm of the virtual, visual, and physical, which I'm passionate about, and I'm very pleased to see this exploration. And I'm saying it's an exploration in the sense you maybe are not fully certain exactly, saying, oh, this equals that. It's an open-ended set of parameters. but it's very creative, very interesting, and that's what a thesis should be about, opening more questions for the next 20 years of your research. It's not that we should have a next clear answer saying, oh, this is done. No, it's just the beginning.
By the way, the installation is supposed to, this is cell growth, so it's supposed to grow for the duration of the Biennale, the 6 months. So the animation part that is projected is supposed to be running. I mean, we don't know yet how we're going to do it, but I don't know if Ben, if you want to show part of that, but I think you did partially, but it was not clear, the animation part. I think the screen, I don't know if it was pixelated or what, but you could also show that, or perhaps you can show a wireframe here of so that it's clear what's actually going to be built versus what's projected. And Alessandro,
yeah, I think we understand on the plan.
Okay, all right.
Pablo, excuse me, can I interject? See,
Carl, hold on.
No, what I'm saying is that I don't see anybody except the screen. Is that what I'm supposed to see?
But hold on a minute, Carl. We go back later with your turn because I want.
Okay, no, okay. Am I supposed to see people here? Because I'm just looking at the image of the project.
You can see both if you swap the views.
Okay.
Alessandro, you want to say something?
Well, let's say it's maybe a sort of question, or in a way interested question, in the sense that I'm very curious to know this. So, firstly, congratulations, great projects, and I would say that the best part is really the concept. So basically, if understood correctly, it's interesting that you're playing with the 3 realities at the same time. So the reality, the physical reality, the forced reality, and the virtual reality. What I find interesting is the virtual reality is the only one who allows both realities, which then become 4. So so this was very exciting for me. It's a bit in a way that in the narrative we see all the things together, because I think this is absolutely the most impressive thing, how to see how this work of the students creates an environment, a space which is beyond the space. We are even talking about a possibility of making, if understood well, war more, because you are saying that the virtual reality is also playing with the different time lapse. So let's say we are talking about 5 realities. So my question is, according to this situation and according to the pandemic situation today, do you see any possibility to challenge the current situation and take advantages of what you have already done? As I said before, in terms of biology, to have done this exaptation, going beyond the scope, in terms of the fact that in your project, if I can make this extreme, the place where this is built doesn't matter. I mean, it doesn't really matter. It's more important the concept and the projection of the project, the different forms. So, can you have you thought, or can you think about using this project as a sort of manifest exploration of this possibility to make a real physical world as, let's say, less relevant than the complexity of this situation? What I mean is, in the final scenario, does it really matter to build this in Palazzo Bembo, or it is better to have in Palazzo Bembo a different representation of this place that is hidden somewhere else? I don't know if it's clear what I'm trying to.
No, but it's exactly that's what we're doing. Actually, I think that people think that we are going to actually build the installation, but because we cannot take the pieces there because the students cannot travel there, that's exactly what we are doing. We're trying to play with a representation of the construction as a kind of way of going beyond the physical and think that this can actually be infinite, right? We're trying to play with the idea of the infinite. If Ben, you want to play more with the model because you're only showing one view, you're kind of.
So if understood correctly, just to understand from myself, if you go in Palazzo Bembo, you will see in a physical, let's say, in a full dimension, the virtual reality, right?
No, there is the animation that is going to be projected in the back of the room, right? Ben,
yes.
You want to show what we are talking about, or you're asleep?
I'm here. I'm just never sure when to cut in. yeah, there's going to be a series of animations that can play, that kind of take the place. There's something we digitally built to kind of represent. To kind of represent the animation itself, to kind of build it. But what's it called? The animations themselves are playing. So this part is a digital representation of what the animation is going to be doing. It's a portal into the infinite to kind of push the perspective further.
So the VR model is tricking you because it's literally physically expanding in the VR model, but while in reality there is a projection screen in the physical.
Yeah, it's just
so it's exactly what you're saying, Alessandro. That
this is what the actual space would
there
look
is a screen
like.
at the back of the display is a screen in Palazzo Bembo, right?
Yeah. That's what Ben is showing now. Ben, go back. This is the reality.
This is what the actual room will kind of portray, except there will be an animation playing, and in the hopes of it being interpreted as a kind of larger three-dimensional space, the kind, you know, so that it can be, so this picture frame is kind of acting as a.
So the question is, but you still, sorry, maybe I lost it. So you have the intention anyhow to build the pieces physically?
Mm-hmm.
Some.
Where? In New York?
Yeah, that was the idea. We don't know what we're going to do because now we just found out yesterday that there is going to be another year. So we are kind of like lost in between translations and delays, right? So.
Yeah, no, but this is exactly what I mean. I mean that this translation is giving us that there is a completely new way of, let's say, spread culture where this physicality, the place could be also hidden. Why? Because we are all coming back, also in my pavilion, coming back. Okay, we build everything there, but now I don't want to build everything back again. It doesn't make any sense. Otherwise, I didn't learn anything from the pandemic. So,
I mean, there's a possibility to visualize it without even building anything at all, using augmented reality and the understanding that through a phone, through a picture frame, you can understand the space without even a single thing being built. I think is that level of ambiguity that has given us an opportunity during this pandemic to kind of understand what has to be built, what can be built, how can we still get our message across, and how can we blur the lines between the visual, the digital, and the physical. And
well, in that sense,
yeah, but I think what they suggested, you could build it here in New York, film it here, and have it exposed there. I mean, you could still have the physical, the visual, the virtual, but multiple place, multiple physicality, or multiple visuality.
We actually have a built installation part in the Long Island campus that we forgot to say, and the idea was to start playing with the two from New York City to Venice. But in that sense, what Alessandro, I think that you're pointing out exactly to the point, which is the same way that we were trying to correlate the virtual model with the physical construction, problematizing the G-code. That's exactly what we're trying to do now at the level of the representation of the installation in terms of VR, right? So expanding dimensions between representation and actualization, avoiding in any case the translation, right? But I don't know.
Exactly. I would not exclude, because what Benjamin said is very clear, and I like it. But in a way, this has been explored, the augmented reality as a substitution. What you have is what Frederick said, the possibility that you enter in a space in New York, and you, through this space, which is a physical space, you are within a virtual or augmented space, which is in Venice, but the physical space actually exists. I mean, this is just to play with the options, not with the alternatives.
Well, that was the original idea of the mock-up, because we are building a mock-up anyways. It just got stopped, but the idea that the mock-up and the virtual now can play a different version of each other. But I don't know, Maider, if you want to intercept, and then with just final comments, because we're running into the other.
Yeah, I just wanted to very briefly first congratulate all the students. If this was like the first time they were immersed within, algorithmic processes, digital fabrication, and so on, it's a very impressive work. And also wanted to mention, like, I find it very interesting the way, like the teaching process, if you like, through what you mentioned, and I'm kind of quoting you here, to create your own computational system. I very much appreciate that way to teach, you know, computational techniques to students, which I could not enjoy back then when we started. It was more like you learn the tools, and then, you know, here is more like this kind of exploratory approach to. So I find that very, very powerful and very probably much more engaging for the students themselves, and probably that's how we see the intensity in the work. So I just wanted to congratulate them, and I gave them the comments before. So, and I wish I saw the video first and then see the project. So I guess now the new jurors are lucky that they saw it, you know, in
you
that
were
order.
inverting
Yeah.
on purpose.
Yeah.
I knew that there was going to be an overlap, so we are revealing and not revealing. But so, okay, I want to thank the reviewers for your time, because we're extending beyond what I originally requested you to stay. So thank you, Fred. Thank you, Maider. Thank you, Alessandro. Galia left already, but I want to sincerely thank you on behalf of the students and New York Institute of Technology for participating. And also, we were going to show a portion of what we are doing with on the response for the coronavirus emergency, which is that the students were developing also masks. Ideally, it's also part of an extension of engaging the body, but we did not do anything critical about it. Just the students were producing masks in their homes with the 3D printing to donate to hospitals. But perhaps we skip that presentation and we do it at the end of the next term. But thank you again for participating. And by the way, very bright comments. So I'm very happy that I'm recording this. So hopefully we're going to do a transcript or something in relationship to a publication that we're working with Marcella, who's also the co-curator of the exhibition part of this project. So thank you again. And I'll invite the reviewers that they just came in. We take a 5 minutes break and then we introduce the reviewers, all right? So thank you again, Fred, Alessandro.
Thank you for the student, for your great work. Thank you, Pablo, for inviting. Take care, guys.
Thank you very much. Great job.
Thank you, Sandra. Yeah.
And nice meeting you, some of those here. Thank you.
Yes, exactly. Great conversation, by the way. All right. Christian, we have Christian Calciu, Ciro Nagle, Marcella, and Matias del Campo. Can we take a 5 minutes break and we come back? Is that okay, guys? Yeah. All right. So yes. we stop for Graciano Valenti also that I'm going to introduce. I want to make a proper introduction of all of you, and Yemi is going to start. We're going to have first a short presentation by Andres and then Yemi. All right. Okay. The students have been working back and forth between individual theses and collaborative projects as a full scale, one-to-one scale installation. And sometimes that's a little bit confusing to understand. So first I want to introduce the second turn of this review. This is New York Institute of Technology. This is a thesis graduating studio. The students have been working on a one-to-one installation for the Venice Biennale in Palazzo Bembo. We just found out first it was going to be delayed until August. We just found out yesterday that it's delayed another entire year. So we're going to have to see how we shift back and forth between those two realities and the scope of the installation. So let me first introduce you the reviewers briefly. The students, I asked for bios, but some of you did send me the bios, some others did not. So I shared whatever I had with the students. But we have here, I'm going to introduce you with alphabetical order. Matias del Campo, Associate Professor at Taubman College in Ann Arbor, and also Principal of Experimental Practice SPAN. The work of Matias del Campo, Sandra Manninger. Sandra, we had her in the previous review, is quite impressive. They have a lot of built work and very experimental projects using both robotic fabrication and simulations as well. Also with us, we have the honor of having Calciu. Calciu is a usual suspect in my reviews, so I'm very happy that Carl, you're here with us. Carl is a special type of architect, I would call. Carl has a lot of experience in some of the systems that we have been using, especially cellular automation. And we're going to hopefully have a discussion about the consequences of certain type of computations or the philosophy of computation or why certain type of computation as opposed to other type of computation. Carl is also currently working on a book on the relationship between, I don't want to misquote you because I know that you may get a little bit.
Let's hear what you have to say.
Exactly. But in any case, you're working on a book that hopefully is going to be published soon about the relation between architecture, philosophy, and computation. Let's leave it open like that.
Gentlemen, that's good enough, yeah?
Yes, good enough. We also have the Marcella del Signore, who's actually a colleague of mine at New York Institute of Technology. She's the co-curator of the exhibition part. We're holding here an exhibition and an installation, and we're working collaboratively with the students with another studio run by Sergio Lizondo, who we are collaborating and also developing a publication. So Marcella has been involved all the way from the beginning. Marcella is an associate professor at the New York Institute of Technology, and also we're collaborating in several projects as well. And she's also having her own installation at the Italian Pavilion in the Venice Biennale. We also have the honor of having Ciro Nagle. Ciro is a special invited guest reviewer here. I usually cannot have him involved enough, so hopefully we're going to have Ciro more involved at New York Institute of Technology. Ciro is a special colleague of mine in many senses. We collaborated together, but to me, most importantly, Ciro is the dean of one of the most innovative schools of architecture today in the world, I would say, the Tela School of Architecture. He's doing a kind of project as we wish several schools are engaging with, and I think that with the leadership of Maria Perbellini and Anthony Caradona, Tom Verebes here, we're aiming to develop a special project for NYIT, and I would argue Ciro is one of those, is developing one of those schools that actually can be recognized by a project, something that I think today has been lost as a type of tradition. So thank you, Ciro, for being here with us. It's a great pleasure to have you. We also have many special guest reviewers, by the way. For some reason, I was able to, we were lucky enough to have them all. Mario Graziano Valenti is an associate professor from Sapienza University in Rome. So it's very late for you, Graziano, so thank you for holding there. I had the opportunity to collaborate with Graziano in many projects when I was a visiting professor at Sapienza University in Rome. And Graziano is involved with survey technologies. He's an expert in perspectival illusionistic representation. And he's also working on kinetic models using paper folding methods for facade systems and so on. So it's also very nice to have you here. We also have from NYIT, New York Tech, Christian Pongratz, who's the senior advisor to the provost. Christian has been involved in multiple reviews, so the students were able to have his critique before. So thank you, Christian, for being with us. Christian is also developing an alternative program at NYIT in relationship to design, which is extremely interesting. And finally, we have Trudy Brens. Trudy is a visiting professor at NYIT, and we have been collaborating with Trudy in Design 2 for now 2 years already. So, and also Trudy has been participating in many of these reviews. So thank you everybody for being here. Just to give you a short version of the reason why we're doing what we're doing. So we're doing a one-to-one installation in Venice. Because of the pandemic, we were actually building the prototype and the Fab Lab had to close. So therefore we changed the scope of the installation to engage different methods, as for instance, large prints, virtual reality, animations, right? A composite of media in order to start problematizing the relationship between not only the virtual and how the project is built, but also the different types of realities that one can imagine in expanding dimensions between the virtual and the real. As I said in the previous introduction, this studio is a mock-up for an upcoming Master of Science in Architecture Computational Technologies that I'm co-developing with Dean Perbellini and Associate Dean Tom Verebes, which I'm going to be directing. We were hoping to start the program this fall, but it's going to probably be delayed for a year. And we're using the opportunity of this collaborative installation as a mock-up for how students can develop their own computational systems, but also their own construction systems. So the idea is to elevate design authorship to the parameters that determine architecture. We have been seeing that in many schools of architecture all over the world, the newest technology is incorporated into architecture, while software developers and robotic engineers have a certain agency in terms of architecture. We would like to invert that equation and think that architects can participate of the current computational technologies revolution and propose from a disciplinary point of view, from architecture point of view, new means to acknowledge reality, new means of surveying reality, and new ways of representing reality, new ways of computationally design reality, and new ways of fabricating reality. In that sense, students engage from an entry level in computation to an expert mode, ranging in variations of expertise, ideally analyzing systems and starting to displace those systems to create their own systems, both in terms of computational design and in terms of fabrication. In terms of computational design, we work specifically with simulations because we understand that simulations are a way of resisting the typical use of algorithms, in the sense that simulations are non-reducible and simulations are non-reversible. I was particularly interested in that notion of computation to try to address other ways of doing computation and to enter an automated robotic way of understanding mechanic systems. Additionally, in terms of fabrication, we were going back and forth with the virtual model and the fabricated model, understanding how to expand dimensions between the two and avoid any linear translation between the virtual model and the build model by modifying G-code and understanding the mechanism of construction as an agent of design. Additionally, I just want to finish that the pandemic response, we had a pandemic response at NYIT, and the students were developing personal protective equipment for hospitals. So trying to engage with the system of fabrication at the level of the mask. So we're going to start now, unless you have any generic question, we're going to start now with Andres, who's going to introduce very fast, 5 minutes only. Andres, why don't you go ahead and present us what you did with the first perimeter parameters of the rooms, and then we jump into Yemi, who's going to explain structural simulation related to his project.
Okay, so I'm just going to be presenting my small part in the whole thesis. It deals with how we are manipulating space to expand and benefit our needs within the installation space. So it's perspective as a visual scale. We began by understanding the rhythms needed to kind of establish a force perspective within this space, playing with where we wanted to put the perspective point, manipulating the depth we wanted to achieve, and then finally coming out with a grid system that we can then overlay my colleagues' kind of columns into the space to achieve more of a visual kind of expansive space. And the final result is something that expands the room to better fit our needs. And then as well to manipulate my colleagues' kind of columns in order to force them into the perspective realm. That's all I have.
All right, Yemi.
All right. My name is Yemi, and for my thesis, I've been working on structure optimization and basically trying to figure out how to create new structural typologies that will help inform new spaces. This is just a brief paragraph basically stating how with the advent of new technologies in 3D printing, it allows us to create different types of structures that wasn't seen as sufficient back in the past, which is why we, to this day, we still create structure and structural systems a certain way. So this is a quick overview of all the different iterations and typologies that I've came up with throughout the semester. And this is, hold on. This is basically the whole process of how I kept on experimenting and came up with different types of typologies. I put this here because this was the very first experiment, something very simple. And from there, I decided I wanted to keep on pushing this idea and experiment more, and started to work with different structures that create a type of branching. And from there, I wanted to also create a space and get rid of, or in a certain way, blur the lines of what a space is and what the structure is, basically trying to get rid of that distinction. So when the user is actually in the structure, they think they're in a space, in a type of space, or the space itself is the structure, trying to remove that distinction between those two. These are just the different iterations. And then I started to also test through structural simulations the different types of structural forces, showing the weak points and of the structure, and also the points where it's at its strongest. And from there, I just kept on going, working on different iterations, pushing it to see how far I could get. Eventually, I decided to do a quick experiment, basically taking Andreas's idea of this perspective view and trying to come up with a column that would fit into that criteria. From there, I did a completely separate experiment, just focused on that perspective grid that Andreas created, and trying to, instead of using the space that we were supposed to use for Venice Biennale, trying to create a space itself using only Andreas's idea. And now we get up to the installation. So for the installation, the only parts that my columns are in is the blue highlighted parts. And basically, I started to run different structural simulations on the columns that would take part in the installation. And from there, I started to use that structural simulation, showing the weak points, to actually inform the 3D printing to remove material where the object is strongest, and to reinforce with material where the object is weaker. I mean, the structure is weaker. These are just the different iterations. And these are a couple of pictures of the 3D printed models. And that's it.
Yemi, you're not showing any detail of the work of the structural optimization.
I could go back and explain that part.
But the built physical model that you did, the last version.
Give me a sec. I'm just gonna show it in Rhino, since it wouldn't do any justice to show the actual 3D printed model.
And you can show some of the drawings that Andres did also, right, of your column.
Okay, so this is one of the columns that I was talking about. So as you can see, in certain areas, it begins to open up. Basically, these are the parts of the model that are the strongest, and the parts where it's reinforced, those are the parts where it's at its weakest. And basically, I try to use that, taking the already optimized structure to then add another layer to the 3D printing by doing this.
And do you have the drawings of the stress diagram in relationship to these openings and the printing that you're talking about?
Yeah, it was. Yeah, they're
okay,
right.
this one,
Yeah.
right? So
Yeah.
if you can, why you have something blocking there on the right? Yeah.
Yeah, I just moved out the way.
So I would zoom into these drawings, right, to show that because it was not clear.
Sorry about that. My computer is acting out right now. Yeah, so basically this outlines the whole step, starting off with the first structurally optimized column and then running a structural simulation on it and then using that to inform the 3D printing.
Do you have any physical models experimenting with the print?
I do have physical models, but it's going to be very hard to show that off on camera.
Did you end up manipulating the G code in relationship to this?
Yeah, I actually did. As
But
you
you're
can
not
see,
showing that.
this is one that's this was the original one, and then I started to play around with the G code, and you can see like the different stringing in some places. I also took pictures, but once again, it's very hard since the size of the model and also the amount of time I had to print it. I had to print a very small model that doesn't really show details in the picture.
All right. Okay.
So what's the difference? Sorry, just a question. What's the difference between the three on the right that you were just showing?
Go back to the drawing.
Sorry. I just didn't.
Yeah.
What are the three showing?
The three is just because this model has a lot of
it's just different views.
Yeah, it's different
Yemi.
views.
Different views of the same model.
Okay.
Okay, so I was thinking that this review could be Ciro, Matias, and Graciano, but whoever wants to interject.
I didn't really get the relationship between the three scales that you are working with. One is the inherited scale of the false perspective organization, repetitious variation, varied repetitious false perspective organization with the typological taxonomy that you made with the subtraction of material related to the structural behavior. I didn't get the relationship in the three scales, basically.
Can you show the plan, Yemi, of the entire installation? You don't have the plan, right? Because Ciro's asking specifically how you come up with the column in relationship to the totality, right?
Yeah, I'm gonna pull it up right now.
Okay. In other words, is this notion that you were explaining before that instead of framing only the space, you're breaking the relation between object and containment relative to the space making in terms of the structural simulation, right?
Yeah, okay. So basically what I'm trying to answer your question, I'm thinking about it in sense of three different layers. So basically the first layer I would say is working with Andreas's grid. and using that to inform the location of the column and what type of space that creates. And then from there, I run a structural simulation on the column showing the stress loads and the weakest points and the strongest points of that column.
But he's asking in relationship to the design, like what's the relationship between this and the floor plan next to the two surfaces that are either side of your column? In plan, do you have a floor plan?
I don't have a floor plan.
But is this the sample that you're making, this specimen that you're making, is that supposed to be running across the whole space, varying in size? Or is it supposed to be located in one specific place?
It's located in one specific space.
No, but the question that Ciro's asking is right, because otherwise it could be anywhere, but it's not anywhere, it's in a specific space. Why is it there?
The columns?
Yeah.
Because we were all using Andreas's grid to inform.
Yeah, but they could be further away or more towards the entrance, but they are there because of what you did with the typology in terms of the column, right? Which are not showing in plan.
Wait, what?
Sorry, maybe I don't understand the exercise, Pablo. Are these typologies supposed to be located at one single spot of the repetition, or are they supposed to be varying across the repetition?
They are supposed to be first varying across the repetition and then find their perfect location in relationship to the exploration. Okay. You're correct. I think that your question is correct. If we had a floor plan, right, then we could understand more clearly the reason why he's operating where he's operating, right? Which is, if you show the fragments, Yemi again. There is a sequence, right, in terms of the installation, and the reason why all of the students were asked to design the entire installation and then recede back to one location, right? So there is a kind of systematicity dealing with the totality and then receding back and finding their own specific location. The first one is a surface, right, that we saw in the first turn of the review that takes over the entire, the first bay, right? So it spans across the space. The second one is kind of intermediate. Then in the case of Yemi that he's explaining now, the space starts opening up, addressing the idea of the perspective, right? So there is a rationale about the relationship between the part and the whole and why those fragments are where they are. It's difficult to understand. I mean, that's why, you know, I wanted to rehearse with the students the presentations, but in Yemi's case, he refused to do that. So it's difficult to understand, Yemi, to be honest. Why you're, I think if you had a floor plan, it would be better, you know?
Maybe picking up a little bit on what Pablo just said, I have basically a comment and a question, if that's okay. First of all, congratulations. I think it's a beautiful project. There's a lot to discuss here. And the comment is basically that I really appreciate that you guys picked up on the tradition, on the architectural tradition of force perspective. I mean, there is like a whole history of projects that dealt with columns and force perspective. Just thinking about the Teatro Olimpico by Palladio or Palazzo Spada by Borromini, there's like tons of examples for that. So basically picking up on this sort of idea and trying to put it in a contemporary age by using novel technologies of fabrication, I think is a really interesting problem to work on. And I just wish there would have been a little bit more of interrogation of that problem as an architectural technique rather than only on a technical level. So that would be highly appreciated. That's the comment part. The question I have is more about the technique that you applied to play around with the topology of the column. So it seems that you were obviously using things like Amoeba and Grasshopper and things like that to generate the columns. But the moment where you start to say that you played around with the G-code to reduce the structural, you know, the mass, for example, of the column, that's a point I didn't understand, because playing around with the G-code would mean for me that you're starting to delete or add manually within the G-code what's happening within the 3D printing of the model, which inherently is difficult to do. And I was curious to understand how you actually did that.
Yeah, that's exactly. Do you want to say anything, Yemi? You cannot. I mean, what I cannot understand is why you didn't take good pictures of your models. If you're saying that you did that, can you show maybe to the screen the models that you did? Is there anything of what Matthias is asking is there a way to show that? Because that's the point of a presentation, right? That you are showing more clearly what you did.
To answer your question, basically what me and a couple of my classmates learned with editing G-code is, like you said, it is very hard and it takes a lot of time, and you have to, basically the only way we figured it out was to go in there and actually change like each individual line. So to answer your question, is just it takes a lot of time.
I'm referring to this. Do you have this drawing, Yemi?
No, that's Andreas's drawing.
Okay, that's Andreas' drawings on your model, right?
Yeah.
I think that if we are working collaboratively, you should have this drawing. Andres, can you show that drawing? Because it's actually, or yes, this type of, you're showing that, right? Okay. So this is what we're talking about, right? This is all the G-code manipulation, right? In relationship to the structural optimization. You see, this is, I don't understand why, you know, like they're crossing each other's files, but then they don't want to show it in their own project, right? So it's a little strange. I mean, I would be proud to show what my colleague was able to do in relationship to my project, right? Can you zoom in, Andres, to show that?
I mean, Andreas did present this in his project, so.
Yeah, but these reviewers did not see that because we are in a second review. So can you zoom in, Andres? You are muted.
I thought I was zoomed in.
No, like, okay, can we see some detail in the right side of the drawing so that Matthias can have an idea?
It's going to be a little pixelated just because of the image quality.
This is an image, okay.
Yes.
All right. But I mean, to me, they're beautiful. I mean, there are two things that are missing that is just merely, this is what is a little bit difficult, right, to teach, because it's like a limit that I have personally. I don't know how to teach this. How you can, you know, like after doing so much work, why is it that it's not clearly shown? I have a limit, a personal limit as a professor to get into the mind of certain students that, because if I were you, I mean, I would clearly show what Ciro's asking. I think it's a fair question. And it's a question that I always wonder, why the relation between the space as a structural containment versus the space as signifying framing versus the space as an object, right? And the entire installation is playing that game. So it will be very interesting to show how you're working with that, because Yemi did a very interesting process in terms of going from a single column framing space around to doubling that column, to triple that column, quadruple, right? And then the space starts being engaged with a structural system, which is quite amazing. I think from my point of view, it's a beautiful design. And then that gets problematized further on in terms of the detail relative to the not only the structural optimization at the level of the openings, but also a structural optimization at the level of the G-code relative to the printing. So it would be great to see clearly that sequence, right? So I agree with the comments that Ciro and Matthias are asking, right?
I mean, in that sense, yeah, I think following what you're saying, Pablo, to me, it's interesting. I mean, it's an interesting project, and it creates a series of conflicts between the three scales that it's dealing with. One being the scale of the space being framed as a totality, as a series of columns. The other being the scale of the column itself as a manifold with a certain operation that proliferates the components or mixes the components. And then the third scale being the removal, the scale of a removal, and the operations that are there to subtract material, which have a specific modality of organization, of material organization. So at all three scales, to me, there is something happening in terms of the relationship between the one and the many, say the one and the many columns, the one and the many components of the columns, and the one and the many fibers of each of the components of the columns. So at all three scales, there is a relationship between the one and the many, and that relationship is, on the one hand, specific to each scale, but then relating to the other scales. So, for example, what's the relationship between removal at the scale of the material as an operation, as a formal operation, and the scale of the manifold of components of the singular column, of the singular multiple column, so to speak? What's the relationship of that in terms of the modality of organization that are happening at each of the two scales, and of how those two modalities either correspond or conflict with one another. The same could happen with the first and the second scale. So I'm wondering at that level, because to me it's an interesting exercise in how space tends to become massive, so to speak, no? Like populated by material, and that happens at all three scales, basically.
Actually, exactly that's what we have been working on. I'm glad that you mentioned a key word, which is what's the limit. And we have been talking from last semester about the fiber. How do you arrive, and inclusively in terms of 3D printing, we have been discussing a lot in terms of removal of material. Can you arrive to the hair, right? To the hair thinness of the material removal, both in terms, and how that plays in terms of the deconstruction that Yemi is doing relative to the single column versus a flock of columns versus nested columns versus nested over nested, right? Until the moment that you don't recognize any longer which scale the categories belong to, right? That was the objective, to play deconstruction both at the typology level of the columnness in relationship to a column inhabitable column, both a positive space and negative space in relationship to the intercolumns, and also at the material level. So I'm very happy that you are identifying that, because that was the real objective of the exercise, until the point of disappearance of the matter. And I think that the fact that some of the models that Yemi is showing now, that they start to break, we wanted to actually test that. How do you print that? You print it upside down, you print it following Frey-Otto's catenaries, Gaudí catenaries, right? How do you print, and how do you exacerbate the idea of removal in terms of the typology of the branching relative to the spatial typology?
Mm-hmm. Yeah.
I don't know if anybody else wants to make any comment.
Pablo, are we supposed to interject now, or are we? You prefer that we respond to the assigned?
We can continue. For you, I had reserved other projects, because I know that perhaps you're not so interested in terms of structural simulation. But if you want to say anything, go ahead.
No, I think I'll wait.
Okay. Yeah, I knew.
Yeah.
But anyways, Matthias, you want to say any other thing?
I mean, first of all, congratulations. I think it's a wonderful project. There are certain things that were not completely clear to me in terms of, because there seems to be like several different final results for this installation, not one. At least it seemed to me like that. I was not sure about this. All in all, I think it's a very well developed project. It's just developed in a variety of different directions. What I would wish nonetheless, but I don't know if this was part of the agenda of the studio, was really the interrogation of the, of the device of a column as something that has a specific history and meaning in architecture, or whether this was really an exercise it rather focused on the way of fabricating things.
No, so, absolutely. No, in that sense, we touched a little bit more in the first review about that. With Mario Carpo, right? He mentioned Alberti, so we were discussing some of those items. To me, there was an interesting evolution of the problem, because sometimes the students were a little bit confused. What I was happy about it, and we talked about it, was the idea of failure or trying and error, activating certain conditions about the columns in themselves versus making experiments, design research experiments that open up other questions. And I think in the case of Yemi, that becomes particularly relevant, because we started with the column as an icon and the column as a sign, right? As a signification of, let's call it architecture, right? From a historical point of view. And what Yemi has been doing is actually fight against that that reading, right? That iconography reading, getting rid of the value of the sign in relationship to its performance relative to two types of making space. A column can make a space and cantilever the space over, like an umbrella structure, or you can have a table structure, right, in which the columns are surrounding and containing the space, right? So in that sense, what Yemi is doing is going back and forth between those two historical ways of addressing structure in architecture.
Yeah, maybe one last thing that I would like to point out or talk about is that basically the exercise of reducing the amount of material in the column in order to optimize its performance as a column is of course dependent on the weight that this column has to hold, right? And the installation you're doing right now, I'm not entirely sure, is, I guess the weight these columns are holding is virtual, right? Because it's not really holding the, yeah.
In a way, the idea was that they were started to make a cantilever canopy space, but they were left at that point. For instance, in Alex, in the other columns, they start reaching each other and creating a canopy, and then the weight is in relationship to holding the canopy, right? But in this case, yes, that's a problem. They're holding themselves, right? But the idea would be that they start addressing a roofing structure, right? Yeah. All right, Tom, here we have Tom Verebes who joined us. Sorry, Tom, before I lost track of all
the pixels of
yes. Yes, so I don't know if you want to make a comment, because we discussed this column many times with you also.
We have. I did, and I don't. Unfortunately, I missed, Yemi, your presentation of it. But having seen the work of your studio, Pablo, and Yemi, your project several times, I'll just talk about the conversation we're having, which is maybe using automated and robotic production for structures which are kind of against the idea of solidity, at least materially, visually, that are not to do with volume or surface, but volume out of a kind of linear, like steel wool-like, felt-like, porous structures that are based on a kind of redundancy that I don't have the language, maybe even structural engineers don't have that language yet, to describe a sort of lightness that isn't the lightness that maybe Friotto and Institute of Lightweight Structures were working on. Some called it sort of swarm tectonics maybe a decade or two ago, but it does away with maybe what many of your columns, Yemi, do, is still have a sort of primary and secondary set of relationships between elements. In these sort of, in the misuse of, say, 3D printing, where you get these furry, hairy structures, there is no primary or secondary set of elements. And I think that there's a really productive area of work to focus on about the misuse of 3D printing for these sorts of material and structural effects.
All right. Thank you, Tom.
I don't know if this is what you were talking about.
Yes, yes, absolutely.
When I came into the Zoom.
Yeah,
so
absolutely.
I'm excited about those sort of misuses of technology that are.
Well, that's a point, you know, like in the misuse to think about analysis, but also how to go beyond the limitations of the tool in order to create new systems of representations and systems of fabrication. But perhaps we'll go to, unless there is anybody that really wants to make a comment. Marcella, you want to say something?
I just want to make a quick comment. Yeah, I think, you know, seeing the installation, I think the group work, I think really helped now, I think, to begin to localize some of these terms and some of these, in a way, strategies. And I think, you know, I think it will be interesting as we progress with the kind of presentation if there is a reference, I think, to the three primary parameters that start to emerge, which is one, I think, is the scalar and interscalar condition of the fragments in relation to space. The second one, I think, is the relational system as a kind of, as a sort of the infrastructure that holds the perceptual and the visual relationship, which is the perspective itself. And the third one, I think, as a scalar condition is the inhabitation. So I think these three are important parameters that start to play within the space as a whole and within the fragments and within the microscale of the material as a continuum. So I think it will be interesting to see the position of the students relative to this as we, I think, we move through the next presentations.
Yeah, ideally the presentations in that sense should be a little bit more clear, because that's the point, right? To have a very clarity in terms of the scale, intervention, what scale at each phase of the project and the process each student was working on, until you come up with into the advancement of the design, in which those scales, they start producing a relationship with each other. They're not just going in scale or going out in scale, but they start problematizing each other. And I think that that was the discussion we were having in the VR model, in terms of the different systems of representation between the physical space, the projected space, the VR model, and the mixed reality, right? In which there is a problematization of the system of representation and an expansion of an idea of architecture in relationship to that. To me, in Yemi's case, in the columns case, is where that is about to happen. Like, in other words, where the real design agenda is in the explosion of the distinction of categories between all of these problems. So to the point in which, that's what I think we were discussing with Zero, right? Until there is a problem of overcoming the problem, and the problem becomes something else. So I totally agree with your comment, Marcella. Perhaps we go to Karina now. Karina is doing a very different type of project and is intervening in different surfaces. So Karina, why don't you hold ahead?
Sure. Hi, I'm Karina Pena, and I would like to share the screen so I can start. Okay, so my thesis name is Dynamics of Humidity and Temperature. There's a recent study that came on May 8th from Columbia University that shows how quickly the temperature and humidity are changing. So we are now experiencing hotter temperatures than what we were expecting. They were expecting this type of temperature to be like in 10, 20 more years, and now we see that it's happening now. So this is interesting, because my thesis, I started thinking about Venice, which is one of the worst temperature because of the humidity in the air. So this makes the temperature feels even hotter. So I was thinking about like how we see these things happening in the how I showed here like some pictures of how the evaporation of the water makes it gets in the water, it gets in the walls, it gets into columns, and how it actually damages. But on the other side, I have an image showing also the beauty of it, how we see that the joints, the injections of mortar into these old walls, Venice walls, bring this ecosystem that I find beautiful. So I wanted to bring that a little bit, and by thinking about that and the projects that we're doing in the interior of the space, I started with a simulation in terms of the outdoor thermal readings. This is readings for the humidity, the wind speed, and also the heat above on the first one. I also have the interior, and most likely we're more interested between May and November, where we were thinking those are the days we wanted to maximize our space in terms of making it feel more comfortable. So after that, I also started thinking, what's the level, where are we as human are more comfortable? So these studies present that between 20 degrees Celsius and 30, we feel most comfortable, or the majority of people feel comfortable at that temperature. So after that, I started thinking, what about if our walls, our interior walls in our presentation tell this story about the change, about the sometimes the cracking on the wall, but more in terms of what we were doing inside the installation. So here I started playing a little bit with some models and creating what physically happens in areas where it's high in humidity. I started to create and exaggerate these within my models using dry ice and hot water. So here I have openings, different openings. Some of them are represent more like the column. So here I have some openings above the column. That's particularly what we know as standard HVAC, which is usually, we always have systems of air conditioner. But I was thinking, how can we bring that to our installation? Is it within the walls that I'm creating the system? Is it within the columns? So here I show some models that show this space between the surfaces and where everything is happening, and we see like this, the movement. So in other words, this is just an exaggeration of the reality, but I was trying to think of in terms of a space, in terms of shapes, what's better for us in terms of our installation space. Some of the models are shown here. Here I show some of the diagrams on how the air, or how I was thinking about these breathing walls system. After that, I started basically, as I said, bringing the models. We already saw this previously. After these, I started thinking, how can we make it more in terms of the fabrication and the computational fabrication. So I started researching a material that is called FCPCM, which is stands for phase change material, that basically absorbs and stores and then releases the heat. So I wanted, thinking of the space that we were creating in this microsystem, I wanted to, in terms of the computational fabrication, to use materials that were not a wall, were not a column itself, but they were the materials making these chemical processes and helping to decrease the temperature within the room. Some of the idea was to where this material needed to be allocated to for it to serve the best in our installation. So that's when I started creating these idea, maybe in some of the walls, maybe in the shell structure that Brianna has. So that's when I started thinking about it. And then I started to actually create the room itself and starting putting people in and calculating for many people. I started from 1 to 8 to see how these changed the space, and the reading was most likely between the 26 and the 36 Celsius, which is very uncomfortable for us. So that's when I started, I knew that that was our issue, and that we wanted to create these between 20 and 25 for it to be more comfortable. So I started to like look into different shapes, the shapes that my colleagues were working on, and I started to do the simulations within every piece. Some of the pieces that I thought were the ones that were going to be more effective in terms of absorbing the heat if we were to use this material that I was talking about. So here I started with Yemi's column, one of the Yemi's column, where I showed where was going to be the hottest in the column, meaning that these areas were the ones that I needed the most of the material for it to work better. Here I still show some of the images of these simulations for Yemi's column, and how we can use these areas and make them better. The second one is another a fragment for of Ben's project. Here we see the readings, and we start articulating ideas of where the best position of the material would be. So here I showed some elevations. I started 3D printing the objects with the material. And then I also did the thermal imaging to show how quickly this material absorbs heat without transforming. And then how quickly actually it releases heat when in a 26 temperature. If the room is 26, it starts releasing or absorbing the heat until it's the most ideal. So here I show some of the models, the same models. I also worked in this fragment. I show the same simulations for this fragment and also the 3D printing with the thermal imaging of these pieces. Here I showed my hand actually touching the material, and we can tell how quickly the material actually absorbs Fox heat. So more models of these fragments of the presentation. And then I ended up realizing that Brianna's surface is the one that actually takes the most heat. So that's the one that I ended up trying to work in terms of the materiality that I was using. And ideally would be like putting the material that changes phase in the top of Brianna's surfaces to help create this microclimate within the room and without air conditioner to make it feel more comfortable. Here are some basically models of it. And this is a quick video on how quickly the material absorbs heat. Thank you.
Thank you, Karina. So Matias and Marcella, if you want to comment, or anybody actually that wish to comment, just specifically, I thought that Matias may know something more, and Marcella. You didn't finish the presentation. You have 42, I remember the other slides.
Right, I'm sorry.
They are tired. You want to continue?
Yeah,
yes, continue. Yeah, just no, not from
yeah,
the
no,
beginning,
I'm gonna
right?
go. No, I know, but it has to go in the presentation mode. I'm so sorry about that. Here it's more technicality at the end. So it's most likely showing how I measure this temperature and how quickly. I have some graphs, and on the left you'll find the pictures of the models that I used. So basically you'll see no material goes equally down. The temperature goes equally down. And then when I started doing it with solid 7 gram, you see a quickly response at the not the middle, but at the beginning of how quickly it went down. Then as we introduce more basically patterns to the 7 gram of material, we see a more rapid change in temperature. So what that informed me was basically that the pieces that have openings and porous surfaces were going to actually work a lot better in terms of bringing the temperature faster down. So here I also showed how each of them work. And like I said, this is more like a technical data in terms of how quickly the material brings the temperature down in terms of the small space of the heating oven, and of course 7 gram of material. Here I show some of the models, and that's it. Thank you.
Thank you.
Okay. Well, maybe I can jump in, Pablo. If Pablo already basically forced me to. No, I'm just kidding.
Because of your what is it? Echo pressures, I remember, right?
Yeah. That's long ago. Okay. Well, Karina, thank you very much for the really beautiful presentation. I think I have to say that I think your initial models, the ones with the dry eyes, are gorgeous. I mean, these are really, really gorgeous images and videos, and I love the idea that basically you started picking up a specific, basically something like analog computing through using materiality, to understand flows and directions and so on. I wish that translation into the digital would have somehow been like the information from the analog would have gone into the digital in a way that it starts really to inform it profoundly. I didn't have really the impression it was doing that, but nonetheless, the results are really beautiful. So the question now is, what Pablo is actually hinting to is a paper I wrote a long time ago, which is called Echo Pressures, which basically was dealing with the idea that you can use natural forces in order to inform three-dimensional digital models. Not the first one to do that. There was a bunch of other people before me who did that, but it's a really interesting way of thinking about that problem. You wanted to say something?
No, that's exactly the point to me. The fact that, early on, some of us who were working on fluid dynamic simulation related to landscape and issues like that, and then the idea was, how can we bring both at the technical level and design level this thing back into architecture, right? So I'm glad that you mentioned that.
Yeah, and again, I mean, it's something that I can always give as advice for students is basically to be really upfront and honest about their references. Like if there is things that influence the work, it's totally fine to say it. There's nothing wrong about this. And I'm a bit curious how that started then to influence the columns, right? Because you have a very specific way where you were dealing with those plexiglass models that obviously were designed to influence the flow of the humidity, and I thought that's kind of an interesting problem. And you mentioned too, like the problem of being in Venice and the humidity in Venice and how that actually affects the architecture, in positive and negative ways, more negative than positive ones. But I would have been curious how that sentiment and idea that is very well defined and formed at the beginning of the project influences then the later result of the column, because it was not completely clear to me, apart from the temperature analysis of the models that are really gorgeous, by the way, too. I mean, your work is really beautiful, but the way how that information flows from one part of the project to the next was something that I would have loved to hear more about.
Yeah, I agree.
Thank you. Well, I think in terms of the first models and the first way of approaching this issue, I was very, let's say, when we know our history and where we come from. So we are fast to go exactly there where we know these columns, that's basically like a small HVAC system. So I went right to where I know what worked, but trying to think about it in other terms of how can I make openings that will help maybe on the top, and that's like, it was a little bit of like what I know and being safe of what I knew. And that's where the first model came. And then when I was a little more afraid of moving was like the other models that you mentioned, where you can tell it's a space between the wall and then it had different waves. So basically for me, it was a trip from the beginning to the end. And what in the beginning shapes of the models were basically informed where I was the most comfortable in terms of what we know, the typical square column. But then getting away a little bit and thinking about changing to another type of material, because maybe the columns were not going to be a column. So that was like a huge transition for me. So
but I think in terms of I think, sorry to interrupt, in terms of what Matthias is pointing out, it's a little bit what happened at the G-code level in terms of other students, which is at the micro level of the material, right? How your analysis is actually changing the design of the surface. That's what I think we are waiting to happen, and I think it's about to happen. And it's those are the beautiful kind of moments in your models in which you started making the readings and recognizing, well, if I open this up a little bit more here and I close it back in another area, I have an informational-based system, a design agency that would start challenging the kind of overall design of the surface, which is exactly what we were discussing with Yemi's columns in relationship to the fabrication. In other words, that the opening of the holes is not only at the level of the structural simulation, but also in terms of the construction, relative to another way of opening up the surface to another design agency in terms of interscalar fluidity, right? Because it's also a fluid dynamic system. So that's what I think that I would have liked to see that happening. I know that you're working on that, and in some cases it reads, sometimes it doesn't read so well, but I think that that's what you're after, literally, right?
Right. Yeah.
By the way, we were discussing something similar with Brianna surface in the first review in terms of using water flows in order to design structural surfaces, right? Which was an interesting conversation, how the different techniques of modeling and simulation, they actually have an agency at the mathematical structural level and at the design architectural level, and what's the relationship between one and the other.
So I'm gonna jump in here. So Karina, I think, congratulations, I think very clear presentation, and appreciate the fact that you started really to talk about the different scales that you tested and the way in which, again, your proposition begins to weave, I think, with the larger narrative of the project. So I think, you know, we were talking about scalar and interscalar condition as a comment, I think, in the previous project. And to me, your project starts to address really the micro, so as a foundation, start to address the micro level of the overall localized performance of the space. And so I think there is a very strong link between material formation, material agency, and micro performance that I think the project start to link. And I think this is pretty strong. So I'm quite interested in the material explorations in terms of microgeometries and in terms of the way in which the material that, again, it's, you know, just looking at the material as a kind of not generic, but very specific in terms of what can do and how this starts to relate to the material formation and geometry. So I think that aspect and the test, you know, the analog test and how these start to really inform the feedback loop within the geometry and the space and back to the material. To me, it's one, you know, very interesting aspect of your project. So I'm really interested also in this notion of dematerializing the space, but again, not really looking at the kind of overall condition of the space, but really this localized condition. And I think, to me, the strength is how your proposals start to attach to these micro levels of the columns, and begin to fill the gap or support certain type of micro performances. For instance, if you look at the columns, you know, from the first project, I'm really interested, again, in this idea of one supporting the other and how the two start to cooperate. And I think this is a kind of narrative of the overall project, right? This notion of coexistence of systems and coexistence of environments at the larger scale and at the macro scale. And so to me, the project has a lot of potential also as a second, you know, way of continuing to research in the long term, and really begin to, you know, really work on and begin to support this interchange notion of micro and formation and agency connected with the material itself.
Thank you.
Thank you.
Marcella, any comments?
I'd like to interject. Can I say something?
Yes.
I think Marcella made a very good point about the micrological properties of the material situations and how architecture intervenes into the local regional condition of that space and of that object, of that materiality, and then how you can then deconstruct, because the premise of this, your studio, Pablo, there's a kind of a deconstructive philosophical background so that you take the traditional conservative notions about architecture and its paradigm and then deconstruct its own semiotic relationship to the user, to the space, right? To various forms of agencies that are interacting in that place, including materiality and computational agency, which I will talk about it later with the Cello Automata project. But I think it's a good point. See, one thing that I'd like to add is that if you go to all the schools, I've done these things also before, but once we use computation, we are implicitly challenging the the philosophical paradigm of what architecture is. So that the relationship of architecture to architect, to what is built world, has been altered. So, but nonetheless, what is interesting right now is to see that we are at the first stage of the intervention or deploying computational systems to the construction of possible worlds in a very broad sense of the term. So I think at that level, I think it's very interesting to see these projects in micrological intervention into specific materiality and this engagement with the subject architect, and how through this kind of interaction, one can deconstruct and redistribute another definition of architecture whereby the subject of architecture as well as the subject as architecture completely displaced. And I think these are the implicit notions that are hovering in all the projects right now. And that's what I'm hearing.
Ideally, I'm glad that you're mentioning this. The objective is at that level and also eventually at the computational level, because if you get specific enough, you would be able to start understanding at the representational level of computation how to engage as a computer scientist does, right? Like, how can you start challenging the conventions of the application of computation relative to those problems at the digital level, and also in terms of the blockchain simulation, right? What are the different types of computation, right? The different types of mathematics, and ideally the different types of robotic systems, not only physical robotic systems, but automated robotic systems. So I'm glad that you mentioned it up, because the objective is that, but it's not, I would argue, the deconstruction part is merely analytical. At a certain point, the objective is not just to deconstruct for deconstruct, but eventually to come up with a new system. What I'm after overall is perhaps to, in terms of what's going on in other schools relative to the post-digital, is to not engage with the semiotics of architecture or the possibilities of architecture, but actually to engage with new systems of architectures. As you place together, you rightly said, possible worlds. What are the possible systems that would allow us to be able to conceive possibilities, right? And to open up thinking modes through the systems of representation. But in any case, we're going to, I think that we are advancing a little bit in the conversation, because, but I'm happy that you're raising that at the level of Karina's project, because if that happens at that level, then I'm hoping that it will also happen at the representational level.
Just one last thing before we move on to the next one. In terms of the concept of ecosystem, ecological system, ecosystem doesn't necessarily entail the world outside there, or the physical properties of the environment and so forth. But ecosystems are also virtual. They're information systems. So the knowledge, any kind of epistemic system, computational agencies are part of the larger global, massive kind of interactive ecosystem that we are implicated in. And that's the level that we have not tackled directly. With the computation paradigm, it requires a new definition of the ecosystem, which is a virtual ecosystem.
Absolutely, absolutely. Yeah, absolutely. I totally agree. I would not add anything, actually. So,
but once we enter into that domain of the virtual, it requires a different kind of implicit ontology. So there's a lot of implicit ontological assumption that's made right here. But so we are focusing on the micrological determination of the specific installation for a specific project with a specific set of issues. But I think one has to open up and understand the global ontology of the computational paradigm in relation to how it alters and modifies and changes and transforms what we know as architecture historically.
Absolutely.
Yeah.
All right, so let's go to the next, because we have 2 projects more, and then we look at how we escape actually the physicality of the installation in terms of Carl's sense. So Isaiah, why don't you go ahead and start your presentation? This one is very different, it's sound related, so.
All right, can everyone hear me?
Yes.
Okay, there you go. Hello everyone, I'm Isaiah. I had the pleasure of studying the interactivity portion of this project alongside with my partner, Ari. My project is called Sensor plus Sensory, Sonic Sensory, excuse me. So my project essentially studies how audio affects the body and how the 5 senses is incorporated with your sensations. Essentially, the 5 senses, including hearing, tasting, smelling, they affect the environment that we live in. More specifically, I study sound. This graph right here is an analysis of how sound is perceived by the person. We have a more vocal aspect, which is in the range of 0 to 5,000 hertz. The musical aspect is in the range of like 1,000 to 15,000 hertz. And then everything out of that is becomes less audible to the ear. So that was a very, very important part of my project, to understand how a person perceives sound and how that sound affects the person's emotions and sort of body. This frequency range at the bottom sort of perceives how loud it is and how low frequencies can become. Okay, so I began by starting a simulation of just a simple like C note. So I'm gonna just play this. So that is just a very simple rhythmic kind of iteration of a play on a baby-like effect. And the same thing being simulated through a frequency changer. So this frequency is allocated certain numbers, and those certain numbers become a higher or lower frequency. As you can tell, that isn't like the best sound to hear, but it's something that I sort of developed over time. This is the same thing, but becoming a more audio effect. So the person's voice is affecting the sound.
Constant frequency, that's nothing. But every time I talk, the frequency goes up. Basically creating a tone.
It's important to understand that each frequency at a certain hertz has basically a graphic representation of it. So I began simulating those frequencies as a graphic just to better understand how frequencies and graphics coincide with each other. Oh yeah, I apologize if it's a bit too loud. You may need to lower your speakers a bit. Now, more specifically, this is an analysis of a frequency between 0 and 5,000 hertz. Graphic representation of 5,000 to 10,000 hertz, 10,000 to 15,000, and then 15 to 20,000. It's important to understand that each frequency has a certain reverb time within a space. That reverb time is ideally supposed to go through 1.5 to 2 seconds. So now this is the schematics that I was recently talking about. This is sort of a play on more of a graphic representation. Now this is another simulation that is simulating how those frequencies from 0 to 20,000 is varying with a room. Now this room setup has 900 square feet. Now it's important to understand that each square footage is sort of depends and coincides with how I'm moving through a room. So that's the first one. This is the second one. Just to reiterate, the reverb time, ideally that I was shooting for is between 1.5 to 2 seconds. Now this is a simulation of showing a partition as the speaker is interjected to the iPad. This 3D experiment is essentially the same thing from the previous slide, just more graphic. Now this is a representation with one object in front of this iPad. same idea, just with a larger object, just to show the different scales of how essentially the columns will be perceived in that room. This iteration is changing of the wall shape. So the wall shape is essentially creating echo of this sound that is being output. This same wall is being chambered in more just to create a different effect. If you pay attention to the number on the iPad, that's going to kind of give you an idea of what I was shooting for. Now, this representation is showing the sound pollution within one room from just one single source. Now, for my project, different sources is obviously understandable because there's going to be a different amount of people within that room. And being that my project is very user-friendly, the different amount of people and the tone of their voice and their movement throughout the space is kind of going to make the experience very different for each person. So this sound pollution was very important in my studies. Now, this is a ray trace. A ray trace essentially is how a person is outsourced and how long that reverb is within that space. Now you can see these different sources are outbanging, and the same thing in section. So each person kind of has their own tone, but the way that the space reverberates the sound is very similar. So I began to change the different shapes of the room just to get a different idea and a better understanding of how the ray trace is perceived. So it's appearing that architecture and the changes of architecture very distinguish the sound that is being input within a room. So this is me correlating those same ideas into the space that we started playing with and interjecting. So this is the space with sort of a perspectile aspect that Andres created, showing the ray trace. This is the same thing with Andres' column and perspective being input. This is the final fragment from the first semester that we iterated and showing how that ray trace is perceived differently based off the square footage that is being taken up within the space. Obviously, something with less square footage is going to show a little bit of less reverb within the room. Now, these are the iterations, the most updated iterations. So essentially, each square footage has its own reverb and definition quality. Now, this is the first particle showing that the speakers are with these blue-like speakers are in the four corners. I wanted to change the different area within those speakers to make the reverb be essential for what I was shooting for. So the reverb on this one is 1.5 seconds. This is the second column iteration. This is the reverb is 5.2 seconds with a 69% definition quality. And the last one has a 1.5 reverb in seconds and a 56.9% in definition. Obviously, we're shooting for 100% definition, but as we all know, that is very unlikely. So essentially, I went with B2, which was this one, this speaker location right here, just because it had the best definition quality. We wanted the definition quality to be as flat as possible, and that was the closest to it. So it had a 65% audible to the ear. And then the reverb time was 1.5 for this B2. Now the speaker location, this starts to play with the perspectile effect that Andres developed, but I wanted to create that same effect within using sound. So the subwoofer in the full range has a very lower audio, which gives the effect of a more bodily effect to the person. They could feel it within their body, and it's based more of bass. As you go towards the perspective, further down, it becomes more coherent, so that the person has a better understanding of how they're moving throughout the space, along with the columns, kind of inferring that they're moving beyond the space. This same effect, just showing how widespread it shows within the section. And then in plane as well. It's sort of this field of sounds that they're moving through to create this perspectile effect. And we wanted to be very dramatic with this, just so that the space feels never ending and continuous. Now this is Andreas's perspective being inferred into the room. Now, that same perspective, in my sense, is perceived as a range of frequencies. It starts off with a very low frequency of 250 hertz, which is more like a bodily, bassy effect. As you move towards the end of the room, it's 8,000, which is more coherent to the ear. And then further on, it's meant to be perceived as 20,000 hertz, which is sort of a void where there's no sound and you cannot hear anything at all. We wanted this to be perceived very importantly. So as you move towards this non-audible void, the perspective extends itself and basically goes on forever. Now this is a scene which sort of makes this into an animation. We were planning on, if we went to Venice, we were planning on having this as a projection alongside with Ari's interactivity and Ben's development as well. So this is giving the effect that a person is moving towards the void. Now the goal for my project was to blur the lines between sound, space, and then the surrounding environment. This is my development of that notation. And lastly, the thesis was developed in terms of audio reactive system. Let's see if I can share this. Can everyone see that? Yes. Okay.
Yes.
So that same perspective
So that
was
same
echoed,
perspective
and it
was
became an audio
echoed,
reactive.
and it became an
This
audio reactive.
This
Kind of makes the user friendly and a unique person in the space.
All right. Thank you. One more? No?
No, that's everything. Sorry.
And also this would be looping in the animation projection, right? In the
Correct.
actual physical installation.
Yep.
Much longer, right? And interactive. All right. Thank you, Isaiah. Any?
Yeah, I had to short it down just for the presentation aspect, but if it was in the space, then it would go on for as long as possible.
So anybody, Christian Pongras has joined us. So Christian, if you want to make any comment, and Tom and Carl,
yeah, sure.
And Matthias.
I think I saw a lot of presentations today, and I think you have to see almost all of them to get a bit of an understanding kind of where the class really goes to. And I think the last two, which spoke more, I think, to what I would call a sensorial interaction, are the ones that help really much more understand this kind of potential. What I think it's somewhere an inscription of space, right, into a new way of perception, which I like. And it brings me back somehow to the question of that Mario Cabo brought up in the prior review. He talked about perspective and this kind of new understanding of vision. And, you know, perspective in a Brunelleschian sense is basically a flattening, right? So it's kind of a translation of touch into vision. And so you can see it, but you cannot touch it. And since we all work in 3D, right, since decades now almost, it's a complete change. It's not perspective. And I think, if I recall well, was Derek de Kerkhove, it's about 20 years ago, I think already, he called it a transcription of vision through touch. And so we as humans, we are shifting into a complete new paradigm, which is a new perceptive method where it's kind of no more a visual dominator, but it becomes a tactile dominator, right? And this kind of tactile inscription, in particular, I think becomes emphasized with music and many other kind of ways of playing to our senses. And I think this is really a very exciting part of this project, maybe and the other ones also before. You know, and the funny thing is, I think in English, we do not have a word for that, but in Germany we call it Raumgestaltung. And there's actually a degree specialization in architecture, in Raumgestaltung, that actually plays very much into questions of sound and in questions of spatial inscription. So really, that's actually pretty exciting.
Actually, I'm glad that you're mentioning the fact that the idea is actually to overcome perspective. The only reason why we work with perspective was a pedagogical exercise to go through the systems of representation historically. But for some reason, they got stuck into the perspective one. That was not the point, but for some reason, they understood that, and then they kept that. What's interesting to me in terms of what you're saying is that what Isaiah just mentioned, right, in terms of the vanishing point relative to so there is a coherent correlationship between the representational sign and the visual sign. That's what makes it tactile, as you're pointing out. So the coordination of different perception modes eventually overcomes one for the other and opens up a different dimension between the two. That's what I'm interested in terms of what you're saying.
Yeah, and I think the difficult part, I think, is, and I think what the students learned is kind of working in teams and actually together play out and understand how each one reads that kind of space and in his own project. So that's a very good learning experience. I think the difficult part here is how much can you give up of your idea and your project and drive the scale in a way that the question of tactility becomes actually really clear the forefront. And I think maybe the weaker part is because students try to get as much of the project in as they can, so the column stays a column instead of a fragment. And I think the question of fragmentation would help a lot more in scaling it up to actually push tactility really to the extreme. And I think that kind of would be the next step. How big can you print those pieces so they still represent traces of the design, but actually play out the larger ensemble of the team.
Well, that was the idea. The idea was to work in topological levels of information across everywhere, so that to avoid the fragment, but somehow the students were less motivated unless they were like physically testing their ideas out in a very concrete way. And that took us back in terms of layering information across the entire room. But one of the aspects of what you're talking about, the tactile, I'm not so much interested in the phenomenological aspect of these things, but to me in the limits of perception. For instance, Isaiah's idea of matching the vanishing point, which is an idea of infinite, with a frequency level of audible frequency level, that to me is what interested me the most. Like, in other words, there are certain things that we are not perceiving, but that are happening with the sound, both at the level of the ear perception and at the physical impact of the sub-buffer zone in terms of bodily absorbing information before processing our brain that information. To me, that's a very interesting idea in terms of taking the tactile, not simply from an experiential point of view, but relating the system of representation at an abstract level with the margins or limits of physical perception. So in other words, I think that there's something else happening with the sound level that goes beyond phenomenology.
Actually, oh, sorry, Carl, go ahead.
Yes, go ahead.
I really like actually that Christian Pongratz brought up the term Raumgestaltung, because I mean, basically the direct translation would be something like interior design, but it doesn't really grasp the term correctly. I think it's rather something like spatial design in general. And that actually describes the project really well, because it's actually using another methodology to really go ahead and do a spatial design within an existing environment, with the columns, with the prints and everything. I thought it's a really interesting problem. But the one thing that really was going back and forth in my mind almost through the entire presentation was the moment when he mentioned 1.6 seconds of reverberation time. And I was thinking, wait a second, 1.6 is actually quite big. That's a lot. That's a long reverberation time. And actually, that's the reverberation time you use for concert halls or for opera houses. That's what it sounds within that's actually the reverb for an opera house. And I thought the cool idea about that is that he's basically using acoustics to manipulate the human mind to perceive the space differently, in that it seems larger than it is.
That's the idea. Yeah, that's exactly the idea. Yeah.
Yeah, and I thought that's really interesting. That's an amazing point, basically.
It's an idea to expand the space in relationship to a sense, right?
Yeah, it's beautiful. So it's a beautiful concept. So yeah.
I'm glad you said that, because initially when I was doing research, I saw 1.6 and I had the same idea of that's a long time. Eventually, I saw that the reverb time for a space art, the small that we had, is a lot less. But then as I got to the idea of the perspective and elongating the perspective, I thought it was perfect for
by the way, there is yeah, go ahead.
Sorry, and talking about simulation, because you use simulation basically to simulate the behavior of the acoustics within that space. The cool thing is that it's rather easy today to manipulate the sound in a way that it sounds like it's 1.6 seconds, although it's not. You just use a reverb, that's it. It's really easy. Yeah.
Exactly. Yes.
So it's really a cool idea. Awesome. Yeah. Also, one point more before everyone else can say is, I really loved your weird vocoder. That machine was awesome.
Yeah, I think Pablo had the same reaction when I presented that for the first time.
By the way, Matthias, in terms of the reverberation, you know that there's only one opera hall in the world that is one and is taken as a reference. That it was a favorite of many singers, that actually there's no echo, because the singer doesn't want the echo. And that's what activated the idea of Isaiah, that if the perfect opera house kills the echo, right? Therefore is one, that means that your voice goes, and when it comes back, actually you don't notice it coming back because it's one-to-one. That's when the idea started addressing the issue that if you distort the acoustic of the space, then you're working an architectural space relative to sound, because you're activating that as a reverberation and an accent. So I'm glad that Also, I know that you like music, so it's a good conversation in terms of that specificity. Carl, you wanted to say something? Yeah.
I'm sorry?
Carl, you wanted to say something?
Yeah, no, I just want to add a short reference. In a very, very general sense, see, I come from a philosophical, I'm not a philosopher, but I come from a philosophical conceptual orientation to architecture. So my critique would be, not so much critique as my response would be primarily conceptual. In a very general sense, we can say that architecture is a subset of anthropology, right? So all the anthropological constraints and parameters that governs architecture is that which we implicitly take for granted when we define architecture. So we practice architecture based on these kind of invisible umbrella of the anthropological constraints and parameters. Now we move into the computational paradigm, and that paradigm is regularizing all the parametric constraints, including the subject of the architect and the subject of architecture, and also the subject as a human being, so that it emancipates away from the anthropological limitation and delimitations of what architecture is. So the reason I'm mentioning that is that project, the sonic project, as interesting and provocative as it is still working within the sonic parametric range of the audible to the human ear. So to that extent, we have to go beyond the infrasonic to the hypersonic, beyond the human range, beyond the delimitation of the human frequency of the human audible range. And that will also open up the sonic universe of possible states of affairs in terms of how, like you said, that you don't see it, but you can feel it. So, you know, elephant, for instance, can feel the ultra, very high, low frequency vibrations. And the other aspect, which I'm getting a little bit ahead of time, is that these musical pieces or these sonic pieces are just one of a kind pieces, right? So they don't have a generative capacity, so that we can talk about the generative music. And I mean, there's a lot of experiment done already, but can you imagine Bach's notion about the harmony of the spheres is a piece composed by Bach? But can you imagine using a generative logic of musical propagation such that these musical agency will have its own internal synthesis and differentiation within itself, so that these sonic formulation can evolve over time on their own accord, so that you no longer need a composer, a musician to compose these music, but the music will generate itself. And that's a reality that we are moving toward. Autonomous generation of the collective holistic ensemble.
No, I'm glad that you're bringing that up.
In that context.
I really like what you're saying, in the sense that, you know, I asked Isaiah to look at Bach, specifically on the Kraft canon, right? The idea of symmetry and non-symmetry and dissonative reference. And I think that if one would be able to do what you're talking about, would be able to understand that there is a relationship between architecture and sound at a different level, and that the generative, once you understand the generative capacity of sound at that level, then the space would acquire that autonomy based on music. And there are actually many architects in the history of architecture that they were correlating rhythm, dissonance rhythm, polyrhythm in relationship to architectural notation. And I would argue that Bach, to me, the reason why Bach is to me the musician is in the sense that Bach was able to go beyond music, right? He created a generative system, autonomous system for music, but it's so universal that one can argue that Bach reached another level beyond music in itself, right? And that's why one can argue that you can do something other than music with Bach, right? And that would be perhaps the horizon in Isaiah's thesis, right? How do you understand a different relation between music and architecture at that generative level, expanding, contracting space at the acoustic level, and then understanding that there would be a generative capacity there to actually calculate space through that notion.
I think it's a really fascinating project, and these last two are probably the most challenging and difficult of the studio, because they both deal with invisible senses. all of the other projects are, the proof is really in the visualization of whether it's, you know, one kind of algorithm or another, one sort of fabrication process or another. And on that level, it's not so much that the other projects are conventional, but they deal with the sense of visuality primarily. And different than, you know, I get excited when I see the visualization of sound. In a sense, the kind of mapping of the qualities of reverberation are kind of fascinating. And I wouldn't see them so much as the kind of the classical idea, and I'm not really an expert in necessarily the history of architecture and music. I've always tried to find reasons to argue against Goethe's statement about architecture being frozen music. Isaiah, your project does prove, certainly in the more dynamic and kinetic models, let's say, that you've made, that your architecture is not frozen by any means. It's more the converse of what Goethe wrote about was, right, music is liquid architecture. In some ways you need to sort of flip those terms, and your liquid architecture is something which has to do with the temporal component of sound, rather than it's a visual still. It's something which is inevitably animate and an animation and happening in time. But I think there's something in the representation of graphically of sound, and there's an ornamental quality of some of those graphic, certainly of the mapping of reverb times and frequency, that tell a certain kind of story about what the way that ornamentation does about each one of those graphic spaces. And it's interesting to hear the discussion about how you would use sound similar to the visual depth of perspective, the deception of dimensional depth through either the classical play of columns or the way that you're using those principles in the installation and in each of your work of the other students. There could very well be a really fundamentally elusive and deceptive form of augmentation through sound. As an architect, I'm more interested somehow in the visualization of that. And similarly to Karina, your project, I can't help but think of both of your projects in some ways, not as the visualization of information as an interim or generative kind of process of design, but actually the augmentation of material spaces. What if buildings or surfaces or materials of buildings are interiors, or you walk by a wall, and there's actually the representation of heat, or there is the kind of sonic representation, and this happens in music, in nightclubs, in the VJ in relation to the DJ, the kind of representation of some sort of filter algorithm that represents sound in real time. But that's really just a very ephemeral and temporal set of effects. What happens if that's a longer term, more enduring, I know that sounds like a quite conventional expectation for architecture to be enduring. There's something to the misuse of in Karina, your work, the ecological basis of simulation of heat and temperature, and applying that in some ways towards the sense of matter or surface or material itself, of having temperature qualities to it. What if that is visualized in some ways? What if that is in some sense the property of materials? I don't know, most of the students, I'm sure you're not as old as us to remember what a mood ring is. The mood ring was one of the greatest scams of the 1970s, selling tens of millions of these rings that had temperature sensitive material on it, and it would apparently show your mood. Basically, it would show the temperature of your hand, from darker to lighter to blue to red, etc. And I think there's an equivalence in architecture, possibly, for architecture to speak about non-visible senses and to actually visualize those qualities, not as frozen and still conditions, but actually in a sense in their dynamics and temporal qualities.
Actually, Tom, since you're mentioning that, here we have some people that have been joining from Europe, and we have Nelson Montas, who's a material simulation specialist. Nelson, are you listening to this, to what Tom is saying?
Yes, I am.
Ah, okay. So you want to say anything about material simulation?
Well, I'll let Tom finish, and then I can probably talk about it.
No, your contribution to the discussion, please.
Well, basically, material simulation is because, I mean, where do I start? Okay, so the definition of simulation is basically you abstract a phenomenon or reality itself, and you pick certain parameters which you want to measure. And then those parameters give you a sense of realistic approximation. That's the most basic definition you can get. And then you have simulations that can do stuff, as we've seen here, that don't exist, that don't have any that sort of become their own reality in a sense. And we saw that a little bit with the project that expanded the perspective space into the infinite or something like that. Which is sort of rooted in reality, but it has its own sort of logic in a sense.
Well, you're talking about autonomy, right? Like in Carl's sense.
Yeah, autonomy in the ontological sense, like its existence. Its existence itself. It resembles reality, but it has its own thing going on. And then there's material simulation, which materials. You basically take the materials environment, so external stimuli, and then material reactions based on their properties, which is what I do for a living, basically. And what I've seen here, well, this project actually sort of touched on that, but it didn't really touch on the materials themselves as much as like what happens through sound waves. So it's basically like an effect, because sound waves bounce out of materials in the environment, which I don't really understand like to what extent was that modeled. I don't think so.
But Tom was referring to Karina's previous project that she was working with the thermal readings.
Oh, that I didn't.
That.
No, that I didn't see. That I didn't see. That's why I'm just giving like the definition, so we can have a conversation about it. Then
because Karina was working with a specific polymer PLA, actually a type of PLA that absorbs heat, and similar to the project that we did for
that we did. Yeah, the chair.
Yeah, the chair.
Okay. So, that would be interesting to see. Actually, I would actually have a question about it. Like, how did you model the mathematically? Like, how did you model the material? Like, what was the framework that you used exactly? Because I wasn't here, so I didn't see anything.
Well, maybe, I mean, Karina, she just used
I did it at the end of the presentation. I was about to miss those analog. It was more like analog than actual simulation.
Oh, okay.
So I basically used, I used like a small heating oven, and then I started measuring the temperature as it went down with no material, and then I started inserting material with 7 grams. All of them were 7 grams, but some of them had different surface patterns. So that informed me like which one worked better and actually bring the temperature down faster. So that I went more analog in terms of that.
Well, you started with the virtual and then you went back to
I started with the virtual in terms of the room in Venice, putting all the information of temperature, like what the temperature in the room.
That's your environment. Yeah, that's your environment information.
Correct.
Okay.
But more in terms of like, what about if there's 1 person or 2 people or like, 3, 4, 5.
Heat charge.
Correct.
Okay.
And
But,
then, but at the level of material, what I measured was more analog than actual simulation.
But maybe perhaps going back to what Tom was saying, if one would be able to visualize that movement, then one would be actually literally designing with the properties of expansion and contraction at the molecular level, changing the from the most elemental particle level, changing the overall strategy of the form at the surface modeling level, right? So I think to me that's a bottom-up strategy, top-down resistance, right? That I think Karina was trying to
basically what she did was an empirical analysis of the material. So she basically ran tests, and that's actually what you do with any material. Like you just test it at first, and given situations, you define boundaries, and you do controlled experiments. That's actually what you did. And then you start measuring stuff. And then you go back and model it mathematically and implement it in a simulation, but by which you do what Pablo's saying. So what Pablo is referring to is actually the second step after what you did. Like that's what I do. Like if I don't know material, like with the chair, we didn't have the chance to do it like controlled. But when we built it, when you built it, you and Gabriel, you actually tested the material itself, and they gave me information so I can put back in the simulation. So the interesting about what you were doing is that you're actually sort of creating a sort of a library of sorts concerning this exact material, which other people can use. Like you can actually publish all that stuff. So, because Pablo also touched right now on something called multi-scalar modeling, which is really hard to do. Like it's almost impossible, but some people have managed to do it with certain materials. Like classical modeling, there's classical modeling and atomic modeling, like if you're dealing with metals. And then there's molecular modeling if you're dealing with organic matter. Okay, so what Pablo just said about the inner structure of a material and sort of like the emergent properties that you see at the macroscopic level being modeled and mathematically sort of formulated, which is what you were sort of extracting with the characteristics, like the temperature, like how it behaves in certain situations. What I do is basically try to classically model. Classically model just means, Newtonian mechanics. Like how to classically model materials that change from, that change happens as an effect, as an emergent effect of their inner structure. Like sometimes it's atoms, sometimes it's molecules, so okay. That's really interesting. Okay,
that's
sorry.
Nice. So, yeah, thanks, Nelson, for the interventions. Tom, I hope that we didn't interrupt you.
Sorry, I'm on mute. No, not at all.
That's why I wanted to let him finish.
I wanted a comment. Sorry about the interruption.
But I think there's maybe Carl too, you were earlier talking about the kind of what is an ecology in architecture. And in some ways it's these sorts of sensory effects that are either something that you embed into the material or you have as a property of an outcome of, a completely different understanding of what matter is and what the ecologies of architecture are. And I just wish we could control these sorts of properties of matter in ways that we would be able to have greater visuality and experience of temperature, of sound. And I think, we do. In Isaiah, when you were talking, you were describing how we sense sound, and that's come up in some of the discussions. I can't help but think, we live in one of the noisiest cities in the world, really, and it's been exceptionally quiet. And I know that this is maybe off the topic of the studio, but in terms of the sound of the city and of generally of architecture, I've felt when I have gone out, like I'm wearing noise-canceling headphones or something. And I'm wondering, Isaiah, what your sense is as a thesis about kind kind of sonic properties in architecture. How working in the last little while, whether you've had a different sense and appreciation for the sound of space at a time where New York has probably been its quietest for decades, if not a century or two.
I definitely agree with that comment. I don't know. The space that we're now sort of like it's something I've never experienced before. Not even just cars passing by or walking in the park, just going to somewhere as simple as the post office. People are just seem more quiet. I don't know if it's because they have masks on or what the case is, but everyone, I don't know. It's a very weird place right now. And then relating that back to my project, it's sort of like I come home while I'm outside and I don't hear anything, and then I come home and play with music all day in this perspective, and it's sort of like I'm living in two different worlds at once. So it's a little eerie.
All right, it's getting a little late and we are still missing another project. So the conversation can go forever, but it's also 6:50. So I thank you for the comments. I really like them actually. And I usually mention Freud versus Lacan. I wish this would continue, but we are still in New York and I don't want to abuse the time of our reviewers. So Ben, you want to present your thesis, please?
Yeah, sure. 1 second.
Please be shorter than normal because just do it fast, you know.
Pablo, I just want to just 1 second. I just want to congratulate all the students and the reviewers because like your projects are kick ass. Okay, so I just want to say that congratulations.
Thank you.
It's a motive. That's the encouragement I needed before I credit.
Before you fall asleep.
Yeah. Okay. It should be this guy. Okay. So my thesis is focused on growth-based systems, like CA. I'm sorry, it's kind of CA and agent-based modeling, and my primary focus was growth-based systems relationship with time. Okay, I'll quickly. A cellular automation is a collection of cells on a grid that evolves through several discrete steps according to a set of rules based on the state of neighboring cells. A popular version of that is the Game of Life by Conway, as well as the Game of Life is a 0-player game. So it starts with an initial state and you engage the simulation and it goes on for X number of generations, and depending on how you set up the initial state greatly changes how the data is going to generate and how it's going to grow or not grow. The rules are based on overpopulation and underpopulation, and the kind of neighboring cells on each kind of generational site is important for that kind of growth and data collection. And my main research was based on developing inhabitable space, or at the very least, visualizing and collecting data on a 3-dimensional level and trying to develop a inhabitable or at least spatial system based on that information. So just a quick kind of, I started with kind of a CA and the level of classes, and 1-dimensional CA is broken down to first 3, and the 4th one, chaotic, is categorized as Conway's Game of Life, but is primarily shown in 2 dimension. So the use of time gives 2D CA an ability to be read in 3 dimensions, and then that data can then be revisualized both as a rigid and a fluid surface. So those relationships develop, data deforms both in the physical and the digital. And the physical can be interpreted as a lower resolution or G-code manipulation. I'll talk about later, but the digital is more about the kind of surface, whether it be closed or open, and how it's being perceived by the person, whether it be a framing object or an inhabitable space, kind of a nesting object. So I can kind of start talking about the rule set and CA as a whole, both one-dimensional, and talking a little bit about what I was just saying. The kind of rule set that you're following determines different patterns and different outputs that you're getting, but still the only thing you're really controlling is that one dot at the very beginning. And that dot can then be reconfigured and to develop a more complex system, even at the simplest of CAs. And in that space, that can be reinterpreted three-dimensionally further. And then going into 2D CA, again, talking about the relationship between the initial state and possible over, under, and general stability in population, and how typologies emerge, whether it be stable and oscillation or a glider, and as well as how the boundary condition can have an effect on not only CA's site, but our site in general, the kind of bounding box that we find ourselves in Venice. And then you can see kind of the same kind of thing spatially, how CA, even in two-dimensionally, can be expressed in a three-dimensional output. And depending on, say, the rule sets, you can start getting an idea of density and the porosity. And then you start expressing not only 2D CA as using time as a recorder in the z-axis to start stacking data, and then both as a rigid and then as a fluid surface, whether it be closed, that is not, it's not a series of different cells stacked on top of each other, but one single surface acting as one. And then how that surface can be opened and be represented as a minimal open tubular surface, and then how that surface can then be reduced and optimized as a kind of skeletal wireframe. And then how these typologies, and I know it's small, but how these typologies, whether it be stable, oscillation, or the glider, can then be re-represented at all kind of levels of both rigid and fluid typological visualizations. And how more complex initial states, oh, that's a bummer. More complex, what is going on? I'm sorry. Okay, more complex initial states can then express more complex growths over time. And then just to get an idea of how those kind of grow both typologically. Get a few. And then how these can possibly grow. I apologize for the lag. I'm not sure if what I'm seeing is exactly what you're seeing, but you know,
yeah, it's a little delay, but it's fine.
Yeah, that's always going to happen. It's just a little too.
Don't worry, keep going.
Much for Zoom.
It's fine.
And then you can start getting the idea of how these both can act as a framing system in the positive negative space, but also as a kind of figure in a field collectively within, you know, space, acting as a kind of traditional column. And then beginning to start understanding how people can inhabit these two-dimensional spaces with a kind of with a scaleless optimism at first, and then three-dimensionally, possibly reducing. And then how the closed surface grows from each point, developing larger and larger relationships until those surfaces start combining and interacting with each other. as well as a kind of developing a surface that is not only interesting, but also easier to print and then re-represent in the physical realm, and get a level of stability with the surface. And how the difference between the rigid and the fluid, kind of a series of cells, can then be represented as one unifying surface. A series of different simple initial states developed by typologies arrange to develop more complex systems, and then experimenting with density within our predetermined kind of site. Get an idea of that. And then kind of physical models, and then beginning the experiment of materiality and translucency, and how the expression of these models can develop past the digital realm. An idea there. And then kind of starting to experiment not only with this was developed when we started figuring out that it's possible that we will not be going to Venice. So starting to get an idea of what it's like to be in this space while it's growing, while it's developing, and how the digital and the physical can maybe the lines can blur only partly out of necessity and partly out of intrigue. You know, that people don't experience the CA and the growth statically at its finality, but at a kind of fluid, its growth over time, you know. Fast forward that a little bit. And a series of those typologies kind of expressed, and how those typologies can then be re-understood in the physical realm using a spiraling surface, and then a lack of heat, so the adhesion does not combine all the layers. So starting to understand how typologies in the physical and the digital realm can express totally different things. And also experimenting with the scale of some of these kind of experiments and how large, as well as how the expression of the digital and the physical begin to get blurred, especially when you get complex structures such as these. You're going to get instances where it overhangs, and things are going to be expressed physically that are not going to be expressed digitally, and that kind of it takes on its own material truth, as well as using a kind of taking a closed surface and representing it as a wireframe, and kind of trying to understand a moire. And you know, you can see here the same object but represented in an entirely different way. And then how that minimal surface starts to develop and grow based on those points, around the points, less engulfing them, but more respectful of its space. And then obviously the same kind of variations, but now expressed in a totally different way. And then a series of minimal surfaces past the typology study of just CA, but now the typological study of how these minimal surfaces can increase in complication or decrease based on its tolerance to the data. Those kind of points. And then, you know, the kind of mass reduction of points here, so that the surface itself almost negates a lot of the points and develops a surface. So object-based, an object-based experience now becomes inhabitable. And then a kind of idea of how these can reduce and develop more inhabitable, capable spaces, and how these can be refined through experimentation. And then the idea of how this can be fragmented, starting to get the idea of where it has to be, where the group installation was moving, it was more beneficial to start experimenting on how multiple versions of both reduced and chaotic minimal surfaces can be expressed in one installation or one kind of idea. Right there. And obviously, in the 3D print, you start to get the idea of it in the same way the closed surface, the material truth, those levels of cantilevers start to represent the linear kind of fabrication of 3D printing, even on a surface. It's still going to be expressed, you know, kind of here and here. That surface starts to decay and almost reveal itself, and its actual kind of material. Its form of fabrication is developing the surface. It's adjusting it based on its physical you know, being physical, as well as the exoskeleton and those same kind of pieces expressed that way, as well as a kind of close-ups of how that kind of opens space up, you know, re-represents the minimal surface and less of a surface and more of this kind of the armature for what the surface would require. And how using that exoskeleton, you get a kind of general idea of what the minimal surface was, but you're able to print the print on the left and the print on the right. The print on the left used significantly more filament than the print on the right, and it's almost doubled in size. So it starts to give you an understanding of kind of finding out more conservative ways to print these in real life that are economical, as well as starting to research other versions of growth-based systems, because we're going to be working with other people, and my fellow students have surfaces, and the idea of possibly swarming and engaging other surfaces with growth-based systems, agent-based modeling, began to be, was another focus, and how that could possibly improve or optimize a surface, you know, but this kind of weaving and crossing of information data. I'm just gonna speed it up because it's a bit of, and some early iterations, and this was when early in the fall we started understanding how that fragment could possibly be understood, and how the space could start to be engaged, and then how the swarm could start to unify all work under one kind of umbrella of what is the material, what is that kind of unifying set of data. Give you an idea of that, as well as this version, and then.
Yeah, you can skip that one.
Okay. And how that growth kind of combines the two variations, both inhabitable space and object-based space, based on my columns as well as Brianna's kind of surface. And then you start to look at the final version and the Catamaran surface, and how the swarm affects that surface, and how it begins to pick and choose its location, and how that can be developed, and how that reduced surface right there, how it begins to be that first kind of threshold, at the perspective, before the perspective starts tapering. And then the kind of initial typology that relates to its neighboring fragment, F4, trying to develop an exoskeleton of branching, starting to, blur the line between one fragment and the other, as well as this typology. It's kind of blinker and then the same kind of field. And then you start looking at taking an initial state of the typology developed earlier and then combining them in the same way and having these moments of emergence and then eventually stabilizing into a series of different oscillating branching, and how that it can be represented later on, and how that material and that surface can almost be deconstructed by its own fabrication method. And the same with that. And then finally, the surface is closed, and it kind of negates that initial typography and grows from maybe not random, but a more loosely based initial state. But you still get the idea that the typology is increasingly prevalent and is the stabilizing unit throughout the sites over time, over the 200 generations grown on this version. An idea of this kind of scale, because its level of height and growth, it gets tapered quite a bit. And then how the space kind of change based on the different CA units and fragments, and then the kind of curtain. And then realistically, the Venice room would have an animation playing and trying to represent the past installation, the part that is past it, and trying to, you know, model the animation space, what would possibly be to manipulate the viewer into thinking the room tapered down to a cone, and then filling it with kind of further growth, continuing the closed surface. And then this would also be shown kind of within the installation, a series of different tapering one-dimensional growth, tapering towards infinity, as well as two-dimensional.
This one is the one that would be running for the entire duration of the installation. That's one of the ideas.
Yeah, these series of different versions.
Because it's just growing, right?
Yeah, that was all. That wasn't repeating, it was the actual growth. It's just as much growth as this one is replicating. As well as how that surface can kind of grow over time. As well as, sorry, missed that. How that space kind of tapers in, and this gives you a better idea of what we're trying to do. That space past the installation is kind of representing the possibility of how we can manipulate the viewer with an animation on that back surface, on the back wall.
But this is the VR now, right?
I can move on to the VR, but
no, you don't need to. But I'm just clarifying that that was the model of the VR.
Yeah. As well as a kind of swarm. I believe.
The only question is, yes, keep going. Yeah.
Yeah, and this is just another kind of view, getting the idea of that unifying piece of information, and this will be shown more specifically in the VR. This the VR is something we're trying to use to blur that line now that we're no longer able to go and interact with the space and put our own installation. We can only rely on drawings of it. The animation and the VR becomes a lot more important to get the image across and the idea of what we're trying to develop. So
the question is, since we are running out of time, if you do the VR just show very fast the VR, because I think some reviewers already saw it. So just that we are talking about the overall installation as well.
Okay, and I'll kind of show an initial walkthrough when you enter the space at its most normal version, if that's the right way to kind of say that. It would maybe be a version that would have been possible other than the past perspective. You get that idea of it moving down, and that line would be the defining point. But other than that, this is how it would be kind of expressed. And then kind of getting the idea of kind of initial wall, you know, more specific views, understanding the neighboring version, and then slowly adjusting. So the kind of level of manipulation, whether it be, you know, the physical surface, and then the CA represented, and then only visualizing the G code of each surface, as well as the less physical and the more digital aspects of our research as a group. And then the kind of swarm superimpose on the G code, and how they're both trying to develop and understand each surface, but in a very different way, how that space and then be increased and manipulated even further through perspective and through focal distortion. And I guess there's one last. Kind of version.
All right, this is, I think, enough. It's okay, we show this one, but we can start the conversation already because it's getting late.
Yeah, of course, whenever.
So keep playing different views and people will talk simultaneously, right?
Not a problem.
All right, who wants to go first? I would invite Carl, Matthias, and then perhaps Tom and, well, some people, I don't know who's left, Tom and Christian. Carl, you want to go first?
Yeah, I have a quick comment here.
Matthias.
That I think that I had the same on a midterm review, and I think first of all, certainly thank you for the great work. Exciting kind of to watch your way of exploration and kind of, you know, the way how you went through that for, you know, pretty a lot of difficult steps here. But I think there's an interesting question of scale again here, and I think the final expression that we have asks almost for a larger scale of that whole, right? I think there's a certain spatial exploration possible that seems to be more within than actually looking at it, and I think that would be for me a next step in that. I think the question of inscribing the space with those structures is certainly exciting, but I think the structures by themselves and within has a scale of the individual module and how it kind of scales up is for me more exciting on the whole.
Yeah, I couldn't agree more. I think like it's interesting at this scale, but I think at a larger scale, kind of devoid of the limitations of this particular site, the more chaotic and complex structures begins to ask a lot more questions about inhabitable space at a much bigger scale.
But I think that's a little bit on purpose in a way. That's what we're after, right? The interscalar loss of reference, right? Mm-hmm. But I think yes, yeah, definitely. Carl, you want to, Carl or Matthias?
Yeah. I think the project is very interesting, but I think I'll take a critical stance if you don't mind me saying so.
Yeah, go ahead, please.
Depends what you're trying to do, okay? Especially with these type of projects. You lose the forest by focusing on the trees, meaning that your project, you're using CA as a kind of generative tool, right? So the system generate all possible states of path, but you just target to a certain manifestation of a certain specific set of rules for a certain finite amount of time, give you a very specific configuration. And then you translate that geometry cells into topology, right? And then from there, you stack them up and you create these kind of a Baroquean, like a Baroque forest of trees. Now, the problem is that when you do that, for me, I don't know what the project is about. Okay, so you're using cellular automata as a tool, as an instrument to generate these kind of shapes. Sure. And these shapes remind me of in the 60s, 70s, if you go to a hotel lobby, you have these wall screens with perforated topological, weaving of knots and so forth. So that's what it reminds me of. Mm-hmm. So I think it's much better to keep the larger picture as well as the smaller picture, both the at different scales. But you don't see the wall by analyzing the grain of sand, so to speak. So you have to capture, especially with these type of projects, the general ontology of cellular automata and what it means theoretically as an instrument and what it entails for architecture. All of these ideas have just completely disappeared in using this as kind of tool to generate some phenomenologically pleasing decorative wall motifs. Okay, I'm giving you a very strong critique of the project. So using cellular automata to generate decorative wall fragments. Yeah, it's relatively trivial in that sense, right? I mean, it's like, a lot of clients will love this. Oh, this beautiful shapes. Depends how you do it, right? Mm-hmm. And that's one thing. Second, that you're resurrecting the Palladio's Teatro Olimpico, meaning that you have one point vanishing system, and then you're calling that an absolute infinite. But the absolute is non-visualizable. The infinite is non-visualizable. The second is that we are moving away from the kind of one perspectival decentralization of an organization of space towards a distributed decentralization of space into monadic particles that are like a field system. And that these field systems, cellular automata is a good example. It's a massively parallel computing model that we have today, cellular automata. So that each of these bits is no longer just one bit of information, but each of these bits is the positional information for a Turing machine. Okay, so the two things involved: one, the ontology of cellular automata; two, the microformation of agency within the system, such as gliders and so forth. And these are agents. They have the kind of an indeterminate will of its own, even though cellular automata is a deterministic system. So I think it's much more important for you from an architecture standpoint, from the architecture of cellular automata as a kind of computational methodology of architecture, to focus on these ideas and not so much to focus on this kind of the material incarnation of a fragment of output of a cellular automata. For me, you completely miss the point.
I have to say, I kind of agree with you, Carl. There are two problems. But I think that on the defense on Ben, there are also interesting problems.
I'm not saying it's his fault.
No, but I agree with what you're saying in principle. And I think, Ben, why don't you put in this view, put the one where the CA is growing? Because there is a difference, and I agree. I think that one of the problems was that Ben worked with this system for the first time, and then he got in love with the result. So I agree that somehow the columns actually were produced very early on in the process, and then he got in love with the actual formations, right? That Carl you're referring to. At the same time, what I think is interesting is the relationship between, because perspective is not Palladio. Palladio is actually critical of perspective. That's why he did Teatro Olimpico. We have to be very careful with that, because Brunelleschi created perspective, right? Developed perspective as a mathematical model, and then Palladio was critical of perspective, and that's why Teatro Olimpico is a representation of the city being cynical about the perspectival distortion as a fake scenographic device. That's why then in El Redentore, he actually expands space and then he cuts space, which is what we're trying to do in the installation, which is to both expand and contract to avoid the normalization of perspective. That's what Palladio did. So in relationship to what you're saying about the monad, as opposed to the unification, I think it's an interesting point, because you're realizing that on the one hand, the CA is losing its character because we are unifying with a perspectival view. But I would argue that that contrast between the monad growing forever and the vanishing point as an artificial signifier of unity is the contrast that I'm interested on. In other words, if one gets rid of the physical evidence of the columns, right, which I agree with you in terms of the figuration, but one focuses on, Ben, if you put the other animation in the VR, if one focuses on the fact that the installation can grow forever, right? But even if it can grow forever, the vanishing point makes a very interesting problem in terms of grow forever, but has a very deterministic reference point, right? So I'm interested in that. I don't know if it is a dichotomy in Hegelian terms, but or if it is a kind of problem in terms of infinite in itself, because you know, you can let this run forever on the one hand, and at the same time you're physically manifesting the infinite in terms of a finite project, right? So I agree with you partially, but at the same time I think that we are activating other problems that are not only that, and I think that that's on purpose.
I want to say maybe another comment to maybe what Carl just also mentioned. I think that the question of cellular automata has been around in architecture since a while, and in that it is kind of a process that we have gone through, and it was maybe important at a time when we thought that systems, if we understand relationships within systems, we can think in multiples. And I think the recent maybe years, particularly new biological systems, right, and actual biological cellular growth systems, even within organisms, told us through research right now that they are not closed systems. So there is rules, yes, but they are heavily influenced by factors that can be within the system, but they're also at the same time outside of the system. And this actually allows organisms to adapt and evolve in ever new configurations, which computation in that sense is kind of a bad simulator, right?
But
so I think the process is helpful for us to learn, but I think the next step, particularly in questions of materiality, is not a replication of a closed system, but is actually the implementation of the code within the cellular material itself.
But Christian,
and then we get to the point that it actually makes an organism and a cellular growth.
But the CA actually is containing what you're saying, because CA is capable of universal computation. So otherwise it wouldn't be a universal computation. In other words, the site-based, to me, the breakthrough of CA is the site-based simulation. In other words, that one state of condition in terms of its computation opens up possibilities. That's why there are a certain amount of rules, but in reality, CA has not been totally consumed as a system. So in other words, some people still argue, right, that CA is capable of universal computation. Why? Because it can contain multiple systems in terms of its own generative system because of simulation. So I would argue, I don't know if I would argue that it would be thought as a closed system in itself, because of the idea that every generation builds up on the contingency of the previous generation, and that cannot be traced back, right? In other words, you cannot develop an algorithm that would
Okay, maybe. Okay, let me give it just one quick comment. We are still in a paradigm where we do computation and then fabrication. Yeah. And in a sense, it doesn't make sense to fabricate what you already do computationally. We need to get to the level where computation sits within fabrication.
Yeah,
it's not two separate things. It does not go from the virtual to the physical and then we look at it. You know what I mean?
I agree with
I think the next step is, and maybe it's another 5 or 10 years, that the computation is within the material, and that's the next.
Well, that's what we're trying to do.
Of what material can do.
Well, you
I agree with that.
You argue that you had a very interesting. You know, we've had this discussion before, and you were placing the relation between the bit and the molecule, right? That as a kind of paradigms, and I thought that was very precise in that sense, and that's what we're after: computing at both levels, so that there's no boundary between physical and virtual, but we're running computations, right?
And you know, Benjamin is probably, I don't know, 20, 21 years old. You know, he is maybe the generation who will work on that at one point. You know, I mean,
So maybe I would like to add maybe 2-3 comments to the discussion. Super interesting discussion, by the way. Now, first of all, Benjamin, congratulations. Really beautiful, beautiful project. Very well presented. Actually, also, I'm a big fan that you're using only black and white and not trying to emulate the color scheme of Memphis design or something like that. So that's great. Yeah.
I had a little bit of color, but I couldn't help myself. But thank you.
So that is awesome. There's a lot to unpack in your project, also because there's so much variety in the way how you approached your final project. And I think it's wonderful to see how much effort and energy and really obsession you actually put in this project. So congratulations for that. I think there's a couple of theoretical problems here. Like Carl mentioned already that there's like a specific ontological problem here, that in terms of how to approach the project, there's something that to analyze how it actually became, how it became the thing that it is. And the other one, I think, that is on the other end of the discussion is the epistemological project, that you're actually analyzing how you generate that knowledge out of this project. And I think that's kind of interesting. I'm not an expert in cellular automata at all, so I'm not really going to discuss that. But there is certain architectural implications here that are really interesting to discuss in terms of how you approached it. I think also Carl mentioned briefly that sort of Baroque figuration that started to emerge in your project, where suddenly you had symmetry present in a very articulated way. And I was wondering about the problem that it seems it's not only your project. I think that's actually appeared in a variety of the projects I saw, which is that columns actually live out of their repetition. Yeah, so it's very rare that you have like 15 or 20 different columns in a space. The rhythm that they generate through their presence in space is what gives space a rhythm and a sequence and so on. And I think that idea of repeating a figure in space is what actually makes it also recognizable for us as architects as being a colonnade, for example, right? So the colonnade is one specific idea of that. So and I wonder whether the sort of variation that is existing in the space is a benefit or a curse for this kind of approach. I'm not completely convinced about that. The other thing is what was discussed also a second before from Christian, was the problem of fabrication and the division between the digital and the analog in terms of its existence and the moment of creation of it. And I completely agree with Christian that the process of fabrication can inherently be the computational process itself. So it doesn't mean to be a divorced entity of being something that is present just digitally and then copied into reality by extruding material in space. I agree that it could be a process that goes hand in hand. And in that extent, so I'm gonna show off now a little bit. We actually created that 2012 at Michigan, where we started doing something called autonomous tectonics, where the process of making was informed by, not by a model that was preconceived, but rather through the process of making itself. And what you showed with those glitches, for example, that started to appear in your model, goes closer to that area where it's not identical to the digital model you made, but actually the physicality of production starts to inform the material existence of the piece. Yeah.
Yeah, that's on purpose, actually, right?
Oh,
That's
yeah,
what we're
good.
after. Yeah.
Yes, so that's perfect. That's great because it
So
really.
the idea is to break, as Christian is saying, you know, to think about the computational model back and forth between non-linearly, right? Because if we think about the linear model, and that's, you know, in Acadia has always been a problem. You know, you are in Acadia very often, right? And
Yes.
the technocratic sort of reference to fabrication in Acadia has been, to me, always a suspicious issue in terms of design. Because if you think about prototyping, not as design, but actually as prototyping production, to me it's a problem. I think that the agency of the designer has to be at the relationship between the two, thinking that the toolpath, in a way, is part of the design, of course. So I'm glad that you're pointing that out. So sorry to interject, but that's exactly the point, right? To break the boundary between the design model and the physical model.
Yeah, great. I mean, that's basically what I wanted to add to the discussion. So again, Benjamin, thank you very much for showing this incredible work and congratulations.
Thank you. And I definitely like the idea of starting to explore the digital and then the reinterpretation. And, you know, was it on, like, the form wasn't made to have these kind of linear drooping kind of portions of it. And I don't know if it was designed based on fabrication or vice versa, but it was kind of like a purposeful accident, I guess is the only way to explain it, you know? And I think the further research is then the same way you were saying, Christopher was talking about, where it was about computing more intentional versions of this kind of this fabrication adjustment from the digital to the physical, you know, more intentional portions of what's happening here and here.
I mean, if you think about what Carl is saying, right? If you go back to the previous image, Ben, because Matthias was hitting on also what Carl was talking about. To me, Carl, the relationship between the particle in terms of the site-based CA in relationship to the surface, the topology of the surface, relative to the fabrication of the surface in terms of the, for instance, when you're printing, right? What happens when you're representing a part of the topology of the surface in relationship to another surface? That's, to me, a part of the extension of that logic of the monad. In other words, that there is a site-based relationship that is playing against, if you want, the idea of unification. And in this case, unification literally is the fact that you can run it forever. And ideally, like for instance, the fact that we did the vanishing point, let's say 50 feet, 100 feet, is an anecdote. It could be as big as the universe, right? So in other words, in terms of what you're saying, obviously this is just to represent a certain condition of actualization. But you know, we could literally make this perspective be ad infinitum, right? If we had the processing power.
Well, I mean, that'll get into another kind of conversation, and at that point, we would have to leave architecture behind. But Pablo, let me ask you, why are you so adamant in using this one-point vanishing perspective?
No, I am not actually. The students, I think in the previous review, we were discussing that. The idea was to take the students through the systems of representation, for instance, first perspective, then simulation of perspective, then Palladio breaking perspective, and then Andrea Pozzo working with anamorphosis. And somehow the students understood perspective and they got stick to that. But I agree, like for instance today, and I'm working with that, right? I'm working with 3D scanning, where thinking perspective is irrelevant today, obviously. I think that it's just, in terms of pedagogy, it was a kind of process for me to show students what are the problems of each of those systems of representation. Somehow they understood the first one and they got stick with that one. I agree, that's a problem, you know, of course.
Because we're living in a post-perspectival era.
Yeah, of course.
In terms of the history of, you know, organization. So I think it'd be much more true to the system if there's no vanishing point. So because CA is a distributed system, so all scattered, so to speak. You are literally moving through the virtuous labyrinth of the universe of C, cellular automata. And so my point is that if you're doing this project for such a kind of a narrowly defined proposal, there should be a thesis, okay, for architecture, not just a thesis for computation, not just a thesis for cellular automata, but they're related to it. But what is the thesis of architecture in this project?
I'm sorry, you were asking me, what is the thesis in regards to architecture? I think it was focusing on CA's typological behavior and its relationship to inhabitable spaces. If the site wasn't Venice, I think the thesis probably would have developed architecturally towards more larger scale ideas and using CA as possibly a starting point for large housing or something to that nature. And I think because of its modular system, as well as its kind of large cell-based voxel modeling, I think that's the most, it's my first place that I would think about, but my thesis is relative to our site. And that's why my research is geared towards a site rather than a specific architecture base, but more so a kind of, installation spatial
Okay,
focus.
all right, I got the gist. Okay,
Okay.
let me put it this way. 30 years ahead of, actually not even 30, 10 years from now, people look at, oh yeah, this is architect in the 90s, it is architect in the 20s and so forth. With this kind of project, not just your project, almost 90% of these robotic fabrications and using these kind of general systems to produce, they look the same. They have the same kind of procedures, the same kind of software system, and the same kind of output. If you don't mind me saying, it's a little bit boring, okay?
Sure.
From the standpoint of a student, you're doing it is exciting. You're learning new things. But after you've seen everything, it's not that exciting. So at that point in time, you said, okay, we've done all these things. How do we crystallize an idea out of this? So far, you have not presented an idea.
Okay.
No, I agree, Carl. That's why we're doing what we're doing, actually, with the students. To go beyond that.
Pablo, I'm not critical. I think it's fantastic that you guys are doing this project. But I'm just saying it for the sake of the necessity to come up with the thesis. And a thesis contains an idea.
But it's interesting that you're saying there's also a feedback problem because relative to new technologies, right? And it's something that we discussed before with you, Carl. If new technologies are new ways of understanding reality, right? If we assume that, right? In other words, the telescope, Galileo Galilei, right? There is a microscope, then things open up. There is quantum computation, other ideas of reality, representation of reality, understanding of reality, and the physics of reality change, right? If that is the case, I'm exactly, that questions the problem of an idea, because if, and that's what I'm after in terms of developing new technologies. I'm interested in addressing what you're saying in the deepest sense. Like, I am also tired. I don't like looking at repetitions of systems that produce things. I'm interested in the parameter in itself and how architecture can actually intervene at that level. In other words, proposing new parameters, right? New technologies and new ways of understanding reality. If we accept that paradigm, right? What I'm interested in is creating, from an architectural point of view, creating new paradigms or new technologies, or in other words, participating of the new emergent technologies, which will propose new ways of understanding the world. I think Brunelleschi did that with perspective. Brunelleschi was able to create a new parameter for architecture from a representational point of view. That's why his idea of representing the infinite with a vanishing point was a revolution, right? The same way that Andrea Pozzo worked with anamorphosis, or other architects, Le Corbusier invented the free plan, right? There are like different revolutions. And I would argue that computation now presents us with the possibility of getting involved at the deeper coding level of new ways of coding reality. And I'm interested in intervening at that level. In other words, it would not be, I don't think that you can intervene at the level of an idea, because if you have an idea, that idea will be in reference to an older system of representation of reality. So in that sense, the transformation would necessarily come up from the discovery that you're doing. So in other words, you cannot have a thesis today, I would argue, because the revolution will be implicit in the system of reference that you would be creating. And I would argue that the most interesting scientists today, both at the level of the molecule or at the level of understanding theories about the universe, are understanding that the way of measuring reality, in other words, the quantum computation is about that, how you measure, the moment you measure a new creation, a new object of representation, and a new reality emerges, right? So how are you dealing with measuring as a problem of emergence in itself? I'm interested in that problem, in trying to figure out new systems of measurement so that you would secure new different ways of thinking. I don't know if I'm making myself clear.
I think you're making yourself very clear. And I think the question that, Carl, you asked, Ben, is the only question that each student should be asked. What is your thesis? But I think it's asked in a way which is certainly fair, but it's maybe premature. Carl, your background with CAs is sort of decades long and deep. Same with you, Pablo. I'll admit my relative ignorance in some sense about CAs, but I see this as a tremendous opportunity to connect. I think what Christian was saying, the relationship between while it sounds so old-fashioned to say the digital and material, rather the computational growth system to the additive manufacturing production system. And that's really where maybe the studio, not on the whole, but certainly, Ben, your project and several of the others that have made that relationship between not so much an algorithm or coding, but the growth system and the fact that both of them really are growth systems. That, to me, I think is something which I cannot wait until that is collapsed into one system. And I think very much that the complexity that's brought by looking at all of this in VR, and if you could design in VR while working within the kind of coding world and the material production world, I think that's I don't even know where that will go. But I think this project is in the context of where you're working. I've just spent, I guess, like many of you, sort of one morning and 2 afternoons on various thesis reviews. And I think relatively speaking, this is a tremendous project. This is one of the most outstanding projects, and also the whole studio, really. And I think the question that you're addressing, Pablo, in the studio and all of the students about the relationship of, once again, terms that seem a bit old-fashioned, drawing and building. And if that relates in some ways to the kind of seminal essay and question that Robin Evans asked about the relationship of drawing to building, that architects, his declaration that architects don't make buildings, we make drawings and models of buildings. And this is a really complex question in the studio here, because you're not making coding to then bring it to machining. I mean, that seems like a simple linear sort of method, nor of the relationship of generative processes to the productive processes. So I think that there's some interim and unresolved questions that probably take several more iterations, projects, studios, more students, other years. But I think my I don't know, I guess my advice to you, Ben, is like, please don't disappear. You know, I mean, keep working.
We are not going to let him.
You know, really make Carl annoyed with you for another few projects.
You like that?
Yeah, I think I could probably do that.
Keep it going. Please set up your office. Go do a post-professional master's. I don't know, do a few projects. Meet all the other people in the world doing similar things. I think we should introduce you to a guy named Christian Lang, who, of course, many of the critics, of course, know very well. He's my former colleague, and he spent years really working on CAs to develop projects on a kind of well beyond the scale that you're working at. Now, I think the question of scale is a really artificial one here. It's one that you decide and assign to what the CA is. The CA, each cell could be room size, it could be building sized. So there is no implicit scale to how you're working. It's a size that's sort of declared in the model space as an application. But Christian spent several projects, years working on towers as the outcome of CA models. And so his columns really are 50 floors, 80 floors tall. And I think it would be really interesting to get the two of you together to talk, and we'll make sure that happens.
And actually, I have to say, Christian, Carl, you did some, Christian worked with you, right? In some of the World Automata projects, right?
That's right. Christian was my student at Columbia. I introduced him to do CA, and he worked for me on some CA project. So we did the tower project that Tom was referring to. But anyway, so that was the early 20 at Columbia. I started CA in 1997 at SoAD. I was the only one at that time in architecture doing CA. But anyway, that's beside the point. But so right now, it all depends on what you're trying to do. So I have realized years ago that what ultimately matters is what Hegel called the true is the whole, the ontology of computational paradigm. And that all these very different kinds of using computational system tools, mapping, whatever, right? Oh, you can do all kinds of strange things these days, endless. And increasingly, the Afghanis are much more intelligently, artificially intelligent endowed, so that they don't need us, architects. The world can generate like a forest on its own terms, okay? It has its own ecology. And this is where we're heading towards. So any kind of remnant of traces of architecture embellishments based on the anthropocentric notion about architecture is nostalgia. I think for now we should begin to make a step towards the future of these type of systems.
But that's what we're talking about, right? Like that the architecture is in the system. There's no architecture. I have to warn everybody that this is going to cut at 8. I never thought that we were going to arrive at 8 p.m. But if we disappear, it's because it's my fault, all right? So.
But before we finish, let me talk about computation in the general term. There's endogenous notion of computation and then exogenous notion of computation. And so far, we're primarily doing exogenous, meaning that computers are a two object, right, in front of us. Is a glorified pencil, except that with the CA, it's a generative system. It's no longer the architect based on the genius of the talent of the architect that you draw sketches like Le Corbusier, or for that matter, Frank Gehry. So right now, for the first time, we're finding autonomous agency that bypasses the traditional notion about an architect as an author. So authorship is completely displaced. So once you start designing, the D-sign is the opposite of what signature, right? So you should look for the deconstruction of signature and sign, a semiotic sign system. But see, right now we see too much iconic references to the paradigm of architecture.
I agree with that. Yeah,
right.
Absolutely.
We have not quite transcended that yet.
Absolutely.
I'm speaking these terms, but I'm philosophically transcending. Right now, I'm not designing.
But in that sense, in that sense, what you're mentioning, Carl, is absolutely necessary to me. And the interesting part is that with one algorithm, I think it's already happening. Architects are going to be gone, by the way, from the outside, from the computational system. By the way, it's unavoidable. So in that sense, that's why what I call the architecture of information is that it's anticipating the fact that the architecture is at the system level and there's no way out of it. So you have to really engage at the deeper coding level and at the deeper robotic level. Otherwise, you're going to have an iconography of architecture rather than a truthful architecture from a systemic point of view. So I totally agree with you. But we have, I don't know if anybody wants to say just final comments. I'm just terrified by the fact that this is going to be cut by my own fault at 8. I cannot believe that we are at 8 p.m. It has been a long day, but fantastic discussion with really high level critics. And I'm very happy that all the critics engage with the problems of the studio, and that we are talking about what we're talking about, which is eventually what we're interested in.
Can I just say something real quick?
Yes.
Okay, so I agree totally with what Pablo was saying, that architecture is in the code itself, or some say. I would argue it's even deeper than that. I've been writing, like I've written 3 articles, but they're all in Spanish, sorry. I'm gonna try to translate them, trying to prove that it's actually in the inner structure of matter itself, that there's a principle called architecture that somehow gets projected into a discipline that we call architecture. But there's something that you can talk about, the architecture of an atom. You know, you can also talk. So that, and I don't have it clear yet. I'm writing about it to sort of develop it. But I totally agree.
Nelson, Carl would be opposite to that.
Okay, Pablo. Now we need another 2 hours.
Yeah, exactly.
Just one. See, if you look at science and physics, up to the early part of the 20th century, physics has been the physics of matter and energy. Okay, and only in the latter part of the 20th century you have physics of information. And so now we're looking at the world as information system. So to talk about matter, I'm not against, you know, phenomenology of matter per se or information theoretic aspect of matter, but you just cannot just simply look at matter outside of the paradigm of information and computational system.
Yeah, but you're actually making my point, because the thing is that matter itself can be, it actually is information. Like there's something below it. Below matter. Matter's just a manifestation of it. So there's several layers and scales. You know, it's like a macro structure that is itself architecture, that holds everything together.
All right, eight last minutes.
Okay, go ahead. I just want to say that.
According to modern mythology, physics in this case, at the very beginning of the Big Bang, you know how much information there was? Exactly. Before matter? One bit of information.
1 bit.
Yeah.
After 13.5 billion light years, the age of the universe, now we have 10 to the power of 120 bits. Okay, so that's how big the 10 to the power.
Excuse me.
Somebody speaking?
Yeah. I don't want to cut you off, but honestly, like, no disrespect or anything, but at some point, this is not being critical feedback to any of the students.
Yemi.
Carl, you see what we're talking about?
I understand.
Okay.
But anyway, just let me finish my statement. So right now, the size of the universe is 10 to the power of 120 bits. Okay, so it has generated from 1 bit to 10 to the power 120 bits, and it's still expanding. So if you have a computational paradigm, then how big is how big of a hard disk you need to contain all that information? But the interesting is that according to the Turing hypothesis, that the Turing machine, including the cellular automata, can generate all those bits, all the possible variations.
Well, that's what I was referring to before about universal computation. But Carl, we only have 5 minutes.
Okay.
I don't know if Tom, you want to close this up? I give you the responsibility.
I don't know if I want to close it up. I don't. We've been going for 6 hours, and the students have been going for 5 years. And really, I think it's just a tremendous body of work, produced in some of the most challenging times that any of us have ever experienced in either the study or teaching of architecture. I really am so impressed how the students have gone so far, and not only was there first the kind of context of Europe going into the pandemic and what's going to happen with Venice and all of that changing from the physical installation to the VR installation or the large format prints in Venice to, of course, the bad news this week, or bad news, I guess, news, there's no such thing as bad news anymore, of Venice being delayed itself, which maybe is great news for your projects. But I think I've thoroughly enjoyed the the discussion and putting the studio into a really high caliber critical context. And I actually think this is great feedback. Your work as students is testament to the high level of your work, is the discussion that it can generate. And that to me is really one of the fundamental reasons why I'm interested in education and teaching and research in architecture, is the capacity of student work to generate the discourse that we all find fulfilling and satisfying, and keeps us going from year to year. So I really want to congratulate all the students just thoroughly. This is probably one of the most challenging capstones you've ever had to end a year, but end your entire degree. And I just hope that all of you, my advice to Ben is don't disappear. Please, all of you don't disappear. Keep working on what you're working on, and stay in touch. And really thank you for the great experience of and the pleasure to join your reviews from time to time. And very much thank you to Pablo to bring you to this point and to arrange such an amazing array of critics. So thank you very much.
Thank you to the critics. Carl, sorry, we have to cut because also I think we are extending too much. But I want to thank you, Carl. Thank you, Matthias, for staying so late. And thanks the students. Before this cut, I want to thank the students for taking, I think that they had a lot of problems in comprehending why we were doing what we are doing. As you can hear from some of the comments, that perhaps they don't understand why we're talking about what we're talking about. And I think that the important thing is to expose them to different ways of understanding not only reality, but actually to criticize the tools that they're going to be using. I don't think that they are aware that they're going to be using computational systems for the rest of their lives. I think that there is an issue there that I want to raise an awareness in the students. And actually, perhaps what we're talking about now is going to make sense in your life in 20 years from now, but that doesn't mean that you have to eliminate it. So just take into consideration what we're talking about. Just think about it. It doesn't need to make sense now. My best professors were the ones that make sense to me later on. Perhaps in the moment I had no clue what they were talking about, but then it starts making sense. I would argue that what we did this year is going to make sense in you, not in 1 year, not in 3 years, maybe in 5 years, 10 years, and hopefully 20 years. And that's what I think that the reviewers here, such as Matías del Campo, Carl Chu, Tom Verebes, they are experimental architects and theoreticians that are trying to get away from the conventions of time relative to the practice of architecture, and we are trying to look forward to what's happening next. And your generation, you're going to be at the peak of your career in 20 years from now, and I think that that's when the things perhaps are going to make the most sense. But Carl, if you want to talk, you want to say something, it's going to cut, but perhaps we'll leave you like that.
I just want to say it's good to meet Matthias, Tom, Christian, Nelson. It's been a while.
Yeah.
Good to see you guys.
Yeah, good to see you. Carl,
thank you, Matthias. Thank you, Christian,
everybody.
also for helping us think about these problems through the year. And thank you, Tom, always being very active in the conversation. And thanks, Matthias, for your insights, and thanks, Carl. All right. To the students, we connect via email so that we recompose the grading and so on, what's missing.
Thank you.
All right. Thank you, Carl. Thank you, guys. Thank you, everybody.
Thanks for the invitation, Pablo. Thanks for having me.
Congratulations. Thank you, Matthias.
Congratulations to all students. Great work.
Thank you.
Good luck, guys. Bye.
Thank you. Bye-bye.
Bye.
Bye.